A very good afternoon to all the panelists. First and foremost, I'd like to thank each one of you for taking your time off to discuss this important topic. The importance of this topic cannot be overemphasized because we all know what we're going through. However, the panel that we've constituted, we've tried to make it as representative as possible. It has got researchers, it has got practitioners, it has got innovators, and it has got citizen interest groups. So we're trying to make it as representative as possible so that many of the action points that we discussed today could probably get implemented on the ground, and kind of remove some of the factors that are impacting this issue today. So quickly, I would ask Nidya to take us through the panelists and the rest of the activities that we planned, and then we'll start the panel discussion. Thank you.
So good evening, everyone. Quickly talking about what BEST cluster is for the benefit of those who do not know. We have many participations from others as well because it was open to the general public. So BEST cluster is Bengaluru Science and Technology Cluster. It's anchored by Indian Institute of Science. And it is one of the science and technology clusters established with the support of the Office of Principal Scientific Advisor to the Government of India and the recommendation of the Prime Minister's STIAC Council to build an Atmanirbhar Bharat through science and technology. So this clusters, it serves as a neutral platform and a formal umbrella structure for all the science and technology organizations in Bengaluru. And we do a lot of other activities like enabling projects impacting the local ecosystem and scientific knowledge and cross-disciplinary capacity building programs. And science outreach is one of the activity among others. So starting with the discussion of this, today's discussion aims to bring out authentic scientific aspects of the problem and the potential solutions to inform the general public. So the agenda is simple. So after the introduction remarks, the panel discussion will be there, which will be a moderated conversation moderated by Dr. Ravi Teneti, and followed by Q&A session where general public can post their questions in the chat box, and there will be some closing remarks as well. So meeting guidelines for the participants, I have enabled mic and the camera for the panelists, whereas this will not be enabled for the audience. So whenever you have a question, please put it on the chat box. We'll take up all the relevant questions. And this meeting is recorded. So this is for information, and so you're consenting to be recorded here. And we want to keep this strictly scientific. So whatever questions and discussions, we request you to restrict yourself to the scientific aspects of the problem and solution. Quickly running through the panelists here, we have a total of 20 members who have joined to speak in the panel, starting with Dr. Ram Prasad Manohar IAS, Chairman BWSSB. We have Director Central Groundwater Board Representative, and we have A.R. Shivakumar sir from KSCST, and we have Maheshwari Madhava joining from DBMP, and Chief Engineer from DBMP, Vijay Kumar Haridas. We have Professor T.V. Ramachandra, we have Professor Mohan Kumar, we have Professor Shekhar Muddu, we have Professor Jagdish Krishnaswamy, we have Professor Sanjeev Sambandhan, and we have Professor Rao Lakshminarayan Rao, and Dr. Farah Ishtiaq from TIGS. And we have people from not-profit organizations. So we have Mr. Shashank representing Well Labs, and Mr. Vishwanath from Biome, and Ms. Sahana from WRA India. And we do have Bangalore Apartment Federation representatives, Mr. Satish and Mr. Arun have joined, and Priyanka from BPAC is there, and Mr. Jay from Initiative for Climate Action is there. And we have a couple of startups to tell us about the new technology. So one is Dr. Srinath from Blue Act Technologies, and we have Swapnil from Uravu Labs. So the session will be moderated by Ravi Teneti, who is head of the Bengaluru Science and Technology Cluster. Over to you, sir.
Thank you, Nidya. Thanks for a wonderful introduction. So quickly jumping into the discussion, we have structured it rather loosely, but what we're trying to do is find out, why we are here, where we are, and what are the kind of what is the research that has that points us towards. I mean, what does the research point out in terms of why we are here? Some scientific solutions, not necessarily all encompassing, even parts of it, if the scientific solutions can be discussed. And then among the scientific solutions, we have kind of layered out, some of the factors that can be controlled and that can be impacted by all of us. So we will discuss that. And finally, we'll also discuss, quickly on the kind of innovations that are available that we can use to make those impacts. So that's how we have structured it. I'll start straight away with Professor Dr. Mr. Ramanorji of BWSSB. Thanks for joining us, sir. Could you just take us through, give us an overview of, the current water crisis, actually if it's a crisis, if it's not a crisis, or just give us an overview of what caused this, and is it a short-term thing or it's a long-term thing? If you could give us a grounds-up report, sir.
So basically, you want me to define the problem. Yeah. Good evening to all of you. I welcome all the participants, especially the moderators of this panel and the various participants across the globe, starting from Indian Institute of Science experts and other non-government organization support and other participants. So basically, Bengaluru has grown exponentially over a period of 15 years. And this particular growth has not commensurated with the growth of infrastructure. And of course, we know that other infrastructure like roads and transport facility, that can be waiting for some time. But whereas the water situation cannot wait for the infrastructure to grow. The last project commissioned by BWSSB in 2012. Thereafter, 12 years have passed over, but the population has grown up exponentially from 89 lakhs to 1 crore 40 lakhs at the present day population. But water capacity of water infrastructure has not improved beyond a point. Therefore, we have proposed that Kaveri Stage 5 project, due to various other factors in administrative delays and natural disaster, COVID issues, that the implementation got delayed than that of actual expectation time. And order to this mystery of delay in execution of this project, disaster of rainfall failure has also ordered that. That's why suddenly the underground water table has gone down beyond a point of recovery. As you all know that geological strata of Bengaluru is much more porous, and the outer zone of Bengaluru, which is currently facing the water issues, have more population pressure due to the highest vertical development. So one side there is a deficit in the supply system. Second, there is a demand in the community for the water. That has created a gap of about 300 to 500 million liters of water per day, roughly. And because of our mechanism to cope up with the situation, like distribution regularization and replacing the water with treated water, and bringing more awareness in water conservation, that has helped us to ameliorate the situation to a certain extent. But the fundamental problem of filling the actual demand and supply gap is yet to happen. Probably commissioning of Stage 5 project by end of May will bring certain amount of filling the gap of this deficit. But however, right now, in the current scenario, Bengaluru has a stable water supply because of our core focus on saving the water. By involving various other organizations like Bengaluru Apartment Federation, CREDI, FKCCA, we are able to create a large scale momentum for conserving the water and implementing a simple solutions like fixing the aerators, penalizing the misuse of waters. We are able to save the water and able to balance the situation of shortage. But going ahead in next upcoming month, May, we may have much more problem to face in case the monsoon is failing further. If the monsoon comes, of course, there will be rainwater harvesting and there will be demand will also come down because of the surface wetness in the system. Though there is no immediate recharging of the underground water, but the psychological appeasement and the rainwater harvesting will minimize the pressure on the system. But otherwise, if the rain fails again in next month, there will be much more in the system. But of course, we are making plans to bring alternative water supply system and pushing more for treated water replacement. To a certain extent, we are confident that in May month we will be able to cross it, provided things are settling well. And the Kaveri Stage 5 project, today also I am coming from the field, so probably by end of May, we will be able to partially commission the project so that the availability of water can be managed. This is the current situation. We have other kind of issues also in Bengaluru that started with the distribution inequity and the cost factor, but still it is all beyond the scope of administrative. It is beyond the scope of scientific domain. It is mainly the domain of administration. Therefore, we will limit our discussion to the adequacy of the water and quality of the water, whereas accessibility and affordability, these two parameters, we'll discuss it later. I am here looking forward to the scientific community to give other areas of solutions. You know, Institute of Science is very, very positively cooperating, and Professor Mohan Kumar is already on the board of our technical committee, and he is giving time to time solutions for our issues. And in fact, Biome, Mr. Vishwanathan also have helped us in giving some inputs from the community. And also Professor Shekharji and Professor Lakshmi Narayan Rao, Professor Ramachandra ji, everybody is giving us inputs in various other forms to balance the situation. Now, this is a formal discussion which we want to get an input of technical solutions from your startup resources or repertoire, so that can be field wise, it can be implemented. What will be the scale of implementation? What will be the cost of implementation? What will be the time of implementation? What will be the feasibility of implementation in the ground? All those things can be discussed. And now the floor is open for the discussion and various suggestions from other quarters. I think the moderator and the documenting team is documenting things and will present a proper report on these issues. Thank you.
Thank you so much, Ramanuji. It was, I mean, you will be called upon with more questions. I hope you don't mind. Going forward, Professor Ramchandra, would you be giving your input on? Of course, we see a lot of your videos, and there's a lot of inputs that you give. Can you also give us today your inputs on why this crisis has happened and what can be done?
Yeah, thank you very much. So the main problem of the water is the absence of water urbanism. We have converted the porous landscape to the bed surface. The city of Bangalore, with the spatial extent of 740 square kilometer, which had 68% green cover in 70s, and less than 8% was a paved surface in 70s. Today, 86% is a paved surface. And, at one end, we are not allowing the groundwater recharge to happen. At the other end, there is a over exploitation. Especially the location, the outskirts of Bangalore, which depends on the groundwater. There is a over exploitation, not just by the residents, the domestic consumers, but also by the building, the lobby. I strongly feel that we should have had a restriction on the builders using this groundwater for the construction activities. That is where BWSSB should have put in some restriction on that, and they should have used the treated water for the construction. I visit the field quite often. I still see that the groundwater is being used for the construction activities. When you look at the city of Bangalore, which receives the rainfall of 700 to 850 millimeter, we get about 15 TMC of rainwater. The best option for the city of Bangalore is the rainwater harvesting. And of course, Shivkumar and Vishwanath are here to dwell upon that. But my agenda is to rejuvenate the lake, and if we can retain the rainwater in the lake, the surrounding, the borewell resources get recharged with the rainwater. That is the best option. The success story we can learn from the Saraki Lake, which was rejuvenated 3 years back. Within a year of rejuvenation of Saraki Lake, we saw the groundwater table increasing by 320 feet. And today, after 3 years, when we visit the Saraki Lake, there's enough water in the lake, and also surrounding groundwater table is good. And because of the high moisture content in the surrounding environment, the temperature in the region is 2 to 3 degrees lower than the city temperature. So that means the solution is in our hands. Only thing is we need to implement those solutions. The groundwater recharge should happen. That is where we have to make the landscape more and more porous, and we need to make sure that we have the mini forest in each ward. Mini forest of 2 hectares in each ward will also help in the groundwater recharge. Wherever we have done the mini forest in Bangalore, in other part of the Karnataka, we have seen the success of the groundwater recharge. The mini forest should have the native species. And when there's a native species, naturally the soil becomes porous because of the microbial activities. And with that, the groundwater recharge happens. So now if we have to solve the problem of water, not just today, the sustainable solution, first and foremost is the rainwater harvesting through the lakes of Bangalore. The second is the wastewater treatment. We need to attain the tertiary level of treatment. Not necessarily we need to have a high technology. This one, what we have done at Jakkur. See, integrating the nature-based solution with the secondary treatment plant will do the job. At Jakkur, we have the constructed wetland and algal pond, which is integrated with the secondary treatment plant. And we do not see any kind of contaminant in the bore wells in the vicinity. So if we can treat the wastewater, then we will have about 16 TMC of treated water, which is available to the Bangalorean. That means 15 TMC because of the rainwater harvesting and 16 TMC because of the wastewater treatment to the tertiary level through the nature-based solution. So that means we will have 31 TMC of water. That is where all of us have to join hands. The government institution, the city administrator need to understand these solutions and make sure that this happens. We do not have enough water in the Kaveri. Kaveri catchment has witnessed the large-scale degradation over the last 5 decades. Our study shows, using the remote sensing data, we have done the land use analysis, which shows the 45% decrease in the forest cover in the Kaveri basin. Today, we have the less than 18% the forest cover in the Kaveri basin. And coupled with the deforestation or aggravated by deforestation, we have changes in the climate. Because of that, there is an erratic rainfall. That's where you see the large number of taluks in Kaveri basin are under drought. So we cannot go on thinking about getting more and more water from the Kaveri unless we improve the catchment, the condition of the Kaveri. That is where BWSSB, when it talks about getting more and water from Kaveri, they should also think about how to improve the watershed condition in the Kaveri basin so that Kaveri can retain the rainwater and which can give the water to the Bangaloreans and all the dependent community in the Kaveri basin. So these are my few suggestions. Okay, thank you very much.
Thank you so much,
Hello?
Sir. Yeah, thank you so much. Vishwanath, would you like to add to this? You have done a lot of work on this.
Sure, I'd be happy to add. Dr. TVR has already commented on many of these issues. I'll just focus on a couple of things which I think we need to work on. Of course, one of them is considering an integrated urban water management plan. Bangalore has been working assiduously at Kaveri water supply. We need to formally look at rainwater harvesting in a formal sense and see how much of it actually we can bring into play. The extent of rainfall is very high, but the ability to harvest that may be limited. My own experience with implementing it at large scale in buildings, apartments, and institutions says that perhaps we may not go higher than 30% of the total rainfall. That may be the practical limit for rainwater harvesting. We need to understand that, and we need to draw up a formal plan as to how we need to do rainwater harvesting. Surface water bodies need critical protection. There is a lot of effort being put in on protecting our lakes. We need to amplify that effort, especially in the periphery of the city, the large lakes like Bengaluru, and then beyond that also those lakes which are outside the metropolitan area currently, but which will be the future Bangalore. Those lakes need critical protection, and they also need protection from pollution, both industrial and domestic sewage. We need to do that. The groundwater management plan has already started. Today, I read in the papers that there's a task force being constituted by the chairman, and that work will begin. We need to draw aquifer management plans, understand each sub-aquifer in Bangalore, understand how best it can be recharged, how best it can be drawn, controlled in terms of demand and supply needing balance, right? So groundwater protection is crucial. With wastewater treatment plants, already the BWSSB is planning a huge investment of about 1,000 crores to upgrade all the STPs. The wastewater treatment plants will be about 59 in number eventually when the Kaveri fifth phase is done, and the treatment standards which will meet NGT standards will be of a very high order. We have enough and more treated wastewater for our city as well as for the surrounding districts of Kolar and Chikbalapur. We need to draw up a groundwater reuse plan. How much of it will be reused for construction, industries, urban use, and for agriculture, plus ecology and environmental reason, that will need to be drawn up. I think as much as we have a task force on groundwater, if we have a wastewater reuse task force also, that will help us to a large extent. Of course, already the BWSSB is putting in a lot of efforts in leak reduction. It's come down to about 27%. And with the fifth phase, it will perhaps come down to 18% of the total water. Perhaps we need to try and reduce it to about 15%, which would be a wonderful global benchmark and standards. I think we have the wherewithal to do a very scientific approach in Bangalore, thanks to the fact that we have invested in the institution called the BWSSB since 1964. We need to help them to become more well-rounded in terms of the specialities they have. Plus, the chairman just sort of did not touch on the issue, but the elephant or the gorilla in the room is how do we manage the finances for the investments in infrastructure without revising tariffs, which is a political decision, which is up to a democratic government to do, which is generally of great reluctance all across India, not just in Bangalore alone. But how do we make sure that the BWSSB has the firepower, the financial firepower to do an investment in a comprehensive plan that it draws up to both extend services quickly and to make sure that the services are under repair and universal in connection. This would be sort of my inputs for this workshop. Thank you.
Thank you so much, Vishwanath. I mean, as usual, very, very informative. Can I request Shashank to say, speak his views on the solutions that can be possibly given? You have done a lot of research on this, Shashank.
Yeah, so I would agree with all the speakers who have spoken before me that like they have mentioned almost all the sources of water that are coming into the city. So like I think the biggest is kind of difference between rainwater and wastewater is that wastewater is perennial. So if you look at it as a resource and then kind of try to optimize how it's being used. So one of the easier, like I think the most acceptable way for reusing wastewater would be if you look at non-potable reuse cases within the city. And then how do you kind of like make a economic case for BWSSB and the thousands of apartments who have their own STP with excess treated wastewater on how they can make it viable for themselves as well as like the people who are using it. And that would kind of reduce the burden on the fresh water, especially the groundwater situation in the city. And the other aspect of it would be looking at the central government has already come up with the framework for safe reuse of treated wastewater, treated water last year in 2023. And that guidelines would help us basically set standards for different reuse cases for wastewater, as well as bring trust into the people who are going to use it or like going to sell it for different purposes. So kind of working together with the policymakers and the policymakers, practitioners, and the scientific community, which all of them are present here today, I think that would be like a great way forward.
Thank you, Shashank. I will call on Professor Mohan to give his view of the integrated water management system, his thoughts on it, and post that we'll go to some of the underlying factors that we can actually control. Professor Mohan, please help us.
Thank you very much. I think my job is much simpler and easier for the simple reason, starting from our chairman, young and very dynamic chairman of BWSSB, till of course right now the Shashank. They literally touched upon what I wanted to say. Directly or indirectly, we all try to do this integrated water sources management in the sense we are going to consider obviously surface water, groundwater, then rainwater harvesting, treated water. Not in Bangalore's case, for example, desalination elsewhere. When you try to look at in any place, there is a supply side, there is a demand side, and supply will obviously come from whatever is the source, generally surface water, then groundwater, then treated water like that. The problem for Bangalore also, I can openly tell you, is that we cannot design water supply system based on groundwater. You're all hearing me clearly. I'm not against, but having said that, it supports 20 to 30% of whatever water we have. In fact, even in our rural water supply scheme, very consciously government has moved away from groundwater to surface water. Why I say that is groundwater is always seen as a buffer. In fact, if we had handled it properly, right now the crisis, whatever we have gone through, we could have handled through groundwater system. Now in this integrated urban water resources management or integrated water resources management, all these things need to come in with a caveat that we should understand the surface water. When we talk about, we are talking about Kaveri, treated water, whatever it is, to the highest 10,500 standard. We should understand whenever BWSP supplies water or any governmental agency or any agency other than the private operators, which we don't even know, they're obligated to supply, mandated to supply quality of water as per 10,500 BIS standards, which they have to do, they have to follow. That means it is potable, drinkable, all those elements whichever we can take. For example, slightly deviating when we try to take the Puri city, it is a small city, of course, but still, they give drink from tap connections anywhere in the city right now. Anywhere you can go, pick it up, not only quantity, quality wise. Now, how do we get the balance among these things? We have three major catchments. All of us know Krishbhavati, we have Hebal Valley, we have. Then also we have the KC Valley. What is the carrying capacity of these valleys? Though we do bring in a lot of water from outside, we also generate a lot of water due to our own rainfall, which goes out. We should also understand we cannot and we should not store all water. Whatever has the natural tendency to flow, we should allow it to flow. Having said that, how much we can retain here and there in some small tanks, how much we can harvest, these are the things which we need to look at, and we need to really take a make a calculation among these things, how we are able to harvest, how much water we are able to harvest in the surface water ponds, how much groundwater is there, how much treated water is moving around, like that we need to take, which I think though here and there some thumb rule calculations may be there, but a very clear cut calculations are not there. That also brings in a lot of equity and inequity in in Bangalore, especially in the south side. More and more surface water is used, the treated water, more and more groundwater is used. Whereas you go to the east side and things like that, as you go along, our LPCD things keeps on coming down. So that brings in, how do we address this issue of inequity through dynamic control? That means measurements you require, proper monitoring you require. That also brings us to some sort of a, whatever you call, digital water management. You must be able to literally monitor what sort of sources are coming in, what sort of groundwater is picked up, what sort of treated water is being used. And having said that, like it also came up, I think very many places, definitely the groundwater recharge we have to do. That support should be available for people to take. And at the same time, we must be able to bring in the treated water into circulation, including dual water supply. In fact, we have already done it. Right now, all of you are sitting in IASC. I can say proudly, my colleague Shekhar is also there, as many of us, including TV Ramchandra, is fully knows about it, where we have done all these things on the campus. You didn't even see the shortage of water. In fact, I had a talk with the other day with Satish, Professor Satish. So the point here is such things which are being done elsewhere. It's not only IASC, many campuses like IIM Bangalore, BEL, so many BIAL campus, they're all doing. So when you try, if the whole emphasis there also, as TVR said, we have quite a bit of infiltration areas. The catchment is there, the recharge can happen. So we have also seen it, for example, in areas surrounding Cubbon Park and things like that, the catchments. So obviously the wells will be yielding because you have mucher area. So we must be able to see, we cannot create the area, but at the same time, whatever is there, we must be able to retain those things, see that the groundwater happens, see that the tertiary treated water is brought into circulation with dual water supply system. And then when we try to do that, the stress is going to come down. Right now, we have 450 MLD of water being pumped. We have about roughly another 600 or something, 800, 600 MLD of groundwater is being pumped. In the fifth stage, we are going to get 775 MLD of water, which, as chairman said, is going to come in another few months. In fact, I should also mention here, why planning is not done or something, I should mention the Tyagarajan Committee report of 2011. In fact, it's a public document. Anybody can go and see. A lot of things what Bangalore can do, including dual water supply, reducing leakage, bringing another source of Kaveri, everything is written there. That's being done. And there is another report of CS2M Hill, which was actually commissioned by BWSSP in 2016, talk about the vision, including rainwater harvesting, especially the peripheral areas. So looking at all these things and integrated planning of all these things need to be done, making sure that the right quality of water is used for right purpose. That way, we'll be able to bring bring down the stress on the drinking water system, and I think we'll be able to manage. This is my opening remarks. Thank you very much. Yeah.
Thank you, Professor Mohan. I have some data points which lead us, unerringly towards the importance of using wastewater, right? Point one is that we.
Oh, sorry. Only one small point I forgot. It's a continuation of what Professor TV Ramchandra said. Of course, BWC is also planning. May not be Kaveri Basin. We need to really revive TG Halli Reservoir, which is closest to with the treated water, with the rainwater harvesting, with whatever it is. We must be able to revive, which was actually one of the sources to the Bangalore city, a dependable source at that point of time. We need to get it back, sir. Sorry about it. Thank you.
Thanks. Yeah, so as I was saying, there are two data points I think that put more emphasis on the wastewater usage. One is that the cost of pumping the Kaveri water is about, what I understand, is about 3 crores a day. That's the cost of pumping the water from Kaveri. And the cost of extraction of groundwater, not including the tanker transportation, is about 2.7 crores a day. So effectively, we're talking about minimum of 6 crores a day of costs just to get the Kaveri water and the groundwater. Whereas, like someone said, wastewater is perennial source of water, right? So I would like to spend a little bit more time on the reuse of wastewater, and here multiple lines of resistance come into play. Strangely, one of the areas of resistance is in terms of the cultural acceptance of using treated water, right, the wastewater. So anecdotally, there is some resistance to that. Can I ask Priyanka to kind of espouse on how do we overcome some of this cultural resistance to using wastewater, either for watering the tulsi plant or using the water for washing clothes or utensils? How do we overcome that kind of cultural resistance in the commercial and residential complexes?
Got it. Thank you. I would like to share that I'm Priyanka Krishnan from DPAC. regarding the cultural acceptance, currently the testing and monitoring of wastewater treatment is something that can be that needs to with time. People need to be able to accept this by sorry, people need to basically through establishing and accepting these standards by understanding that these have been treated adequately. We will see this change with time. But whereas when it is the current state that we may not be currently ready for maybe washing clothes with that, or taking bath with wastewater treatment currently. But instead, if we could use this for construction, or if we could use this for gardening, that could reduce our need for water. Our requirement of water can be definitely reduced by doing these, so that we don't waste like any amount of water should not be wasted. We could use it for these different purposes, but it coming into these other areas of household uses, it may take time for that change to happen. So if I could add in a few points on our thoughts here. So basically I want to add that 2 points that we need to give importance to is saving water, and the second is to stop polluting the water. So saving water in terms of rainwater harvesting, like how we spoke, then even having bioswales to have infiltration or percolation into the ground. So how we design our streets and how water flows in these stormwater drains, can they be of a duct design to help move through the trees, and maybe thoughts on those ideas would really help. Can we reduce the transmission and distribution losses as we distribute water? Then about reporting water leakage. So BWSSB has this number 1916. I'm not sure if many are aware. In fact, I reported one of the leakage, which I was seeing for almost a year, but I would forget about it as I walk past by. But with this water shortage that we have, I just checked the number. I got the area supervisor's number, and it was immediately fixed. So we need to be careful of how we use our water. We need to conserve it. Even RO reject water can be used for washing cars or mopping and so on. Kitchen water, like the water we use for washing rice or pulses, can be used for gardening. And treated wastewater, like I mentioned, for gardening, construction, flushing, which many of us are trying to do, and bringing in aerators. In terms of stopping polluting of water resources, one is we tend to be throwing garbage, our swept dust from our houses, from our front yard and backyard, and even the construction debris tends to be going into these nalas or into our stormwater drains, which is not really helpful. And later we end up wondering, why is the water polluted, or why is there flooding? Two other things which I think many a times we don't think about is about discarded cooking oil. Many a times we heat oil and deep fry food. What happens to the oil after that? Many a times I think this oil goes into the sinks and flush tanks, which is not okay. We need to find ways to reuse that. It can be even for lubrication and mechanics. Paints and thinners. There is currently no policy to see where these are, how are these discarded, or what's done of it once a construction is done. What do you do with the remaining paint or thinners and the brushes and so on? So these also pollute our water bodies. Sewage mixing in stormwater drains is a major issue that we all identify. And lastly, using slope nuts and bioenzymes, that would really help have our water in a much healthier condition instead of using chemicals into our water bodies. So I think what I tried to mention here is methods we could take as individual citizens as well, and how each of our actions do make a change on the condition of water bodies around us.
Thank you, Priya. I made a note of many of your points.
Thank you so much, sir.
Yeah. So one of the other resistance to reusing wastewater is the fact that there is a lot of waterborne diseases that happen. So Farha, can I request you to share your thoughts on what kind of surveillance mechanisms we should
Right.
use? Yeah.
You can hear me, right? Okay.
Yeah, we can hear you.
Yeah.
Farha.
Yeah. So yes, so I think I've been listening to all of the discussion, and I agree all the points here. And I think in terms of the using the treated wastewater, and I think one of the very important thing that is currently missing is that understanding the health risk which comes with the wastewater. So we've been, for example, looking into the wastewater surveillance for different pathogens in the city, both inlet and outlet. This is after the treatment from the different sewage treatment plants. And it started off as a SARS-CoV-2 project, but then we are expanded it to other, pathogens as well, looking into all waterborne or other kinds of diseases. And also to understand like what kind of, change do you see in the abundance of different pathogens? And knowing that Bangalore has such a huge water footprint, we also expanded this work to some of the outstation sites as well. And you do see a change in the gradient, like how the pathogen load decreases. But having said that, that doesn't mean that it's completely gone. And I think the issue of that we must make a case, and I think it's a very important point to reuse this treated water. But at the same time, I think where you have these farmers, using the treated water for, say, agriculture, and we as the city dwellers are having this food security, it's a complete circular economy in this water scarce world. But also this kind of surveillance, I think, is very important to understand that how the health risk can be minimized. And I think there's a huge scope for it, that we must integrate this wastewater issue with this continuous surveillance. And I think that's one of the ways to minimize these different outbreaks of, say, the cholera or salmonella, which happens in different parts of the city. So all I'm just saying is that the sewage is very, very intricately, related to understanding the health of the whole community. But at the same time, the surveillance gives you insurance that where we are in terms of the water we use currently in the city. Yeah, thanks.
So Farha, what do you suggest that, how do we operationalize or execute some of these surveillance methodologies, considering that, a large part of wastewater is generated by apartment complexes and commercial complexes?
Yes, so there are no measures right now, right? Like the way the water is being even tested for what kind of pathogens or even heavy metals or other things the water might be carrying. I think some of those things needs to be enforced to understand how safe this water is, even if it is to be used for industrial use for other purposes. And I think it's the same is for the agriculture use as well. So for example, we started off looking into understanding that what kind of antimicrobial resistance genes do you see in the wastewater, which is actually used for agriculture purposes, both in some of the parts of the city, but also outside the city. And we all know that AMR is a huge problem. It's like a silent pandemic, which is building up. And the amount of exposure we all have to that just by having this in our environment is amazing. So having a kind of a system where we are continuously surveilling from the different outlets where the water is coming to the, say, lakes or to different, say, or in the other environment, I think very important to understand, like, what are those pathogens which really matters for the city and we must look for, and how we can make it safe for reuse. I think Vishwanath, you can add more. You've been working with us on this. So yeah, please go ahead.
Just one sentence. I'm sorry, I've already taken my time. But working with Farha and DIGS on this particular issue with the BWSSB, every one of the sewage treatment plants of the BWSSB has been tracked over the last 2.5 years by Farha and team in both AMR as well as SARS-CoV-2 and many other pathogens. If we have a reuse policy, which will come in with the BWSSB, it will be easy for the BWSSB to do the tracking, wastewater surveillance, and it will be the first that a water supply institution does that. So it's right on top of the agenda, because the health of the city, the wastewater reuse are intricately linked. And the pathway has already been shown by TIGS and FARA. We need to carry it forward and embed it structurally as part of the testing process.
Thank you, Vishwanath. Thank you, Farah. Jagdish sir, you have been a big proponent of blue-green cities. How do you, I mean, with the way that Bangalore is today, what are some of the steps? I mean, we cannot roll back what has happened, but going forward, what would be some of the suggestions to, create this blue-green kind of concepts in Bangalore?
Yeah, so while I start, if I can request Nitya to just show that map which I have prepared, just to share with you the blue and green infrastructure that we already have in Bengaluru, thanks to historical legacy, but also other recent steps taken to protect lakes and so on. We do have a infrastructure which is already there, blue and green. I just want to point out one part of the water cycle that so far we have not talked about. That is basically the green water. That is the water that's accessed by plants and released into the atmosphere through transpiration. And this is and also the evaporation coming from the lakes. This is what provides the cooling mechanism for large parts of the city. So here you can see this map, which is showing the city average temperature has been subtracted from every pixel. So what you can see is either the warming with respect to the city average temperature or the cooling with respect to the city average temperature. And you can see the crucial role of the green and blue spaces for this evapotranspiration based cooling. Now, this is a cooling with respect to even a few degrees Celsius is going to make a huge difference to the comfort and well-being of citizens of Bengaluru, especially under future climate change. As a city, globally, anyway, it's going to get warmer. We will need more of blue and green infrastructure to play a role for cooling the city, apart from other benefits they give us, including, for example, recharging groundwater, aesthetics, cultural services. And right now, some of our blue infrastructure is not in a very healthy state, but some are. So the areas, blue infrastructure, which is well protected in its catchment with the green spaces, they are likely also to have a better quality of water, which means that those water bodies can be prioritized for. In fact, in the future, I don't see any reason why the water coming out of some of these blue spaces might actually be fit enough to be treated and used even for drinking purposes. But that is something that we have to plan for in the future. So that is one aspect. The second thing is that we also realize that the green cover that we have in Bengaluru right now, some of it is actually subsidized by the water that we are bringing into the city. So the seepages and leakages, and also the water sometimes people are using for gardening and other purposes, they are using basically good quality water. So moving forward, the treated wastewater will have to be the first source of water for maintaining our blue and green spaces. And vegetation, when it interacts with the water, which is of not very good quality, over a period of time, both through bioswales, has been mentioned by Priyanka and others, also the vegetation in and around these wetlands, as well as the vegetation around the wetlands, they can actually help improve the water quality. And that is basically your nature-based solution for improving. So it's possible that a proportion of the lakes in Bengaluru in the near future can actually act as sources of good quality water, being supported by having input as treated wastewater or wastewater. So we should not be using good quality water for maintaining some of these green spaces. I think that is a point which has been made by others. And because we will need a lot of these green spaces in the near future for cooling the city, especially in the summer. Of course, this is an El Nino, super El Nino year. 2 years back, when we had about 1,750 millimeters of rainfall, we had flooding in parts of Bengaluru, including some of the lakes. Now that is one so which means that every year is in some sense a special case for us. So in that year, for example, we could not find a way of that bounty of rainfall that we had and the runoff that we had because of the high proportion of built surfaces in many parts of the city. The high runoff potential which is there, that needs to be channelized into gray infrastructure, that is through radical ways and other type of structures, and conveyed to other water bodies. So that system needs to improve so that the bounty that we get in areas with high runoff, instead of interacting with the poor quality water, with solid waste, and with all our choked drains and all, eventually we need to have a system where that runoff, high runoff, which is currently flooding parts of the city, can be efficiently channelized into either become part of water bodies or convey or help recharge the groundwater. Basically keeping that water out of harm's way. That is going to take some time, but I think that is so you need, it can't be done simply with blue and green. It needs to have integration of gray infrastructure along with blue and green. So that is basically one of the points that I wanted to make on where do we get the finances for maintaining blue and green infrastructure. How do we reward a campus which is doing a very efficient job of maintaining, of recycling its water, maintaining its green spaces, and providing actually a lot of benefits to the citizens living around. Now we know that the government of India has this green credits policy. These are transferable. So basically, these are meant for offsetting emissions and other things elsewhere. There's quite a bit of controversy around some of the guidelines and things, but eventually, this is something that we'll have to deal with. There is no reason why the green and blue spaces in Bengaluru, including individual campuses which are really doing a good job, can be rewarded through green credits. So that is something that we need to look at because the resources are required for maintaining gray, blue, and green infrastructure, and we need to find a solution for that. The second point is that many of these green spaces in Bengaluru are also very rich in biodiversity, whether it's the GKVK campus, whether it's the Indian Institute of Science campus, or even my own IHS campus in Kengeri. Many other places are very rich in biodiversity. Now there is now a category called Other Effective Area-Based Conservation Measures. It's called OECM. It's a new category of conservation, which any place which is not meant for biodiversity conservation, but where the biodiversity conservation is a co-benefit, they can apply for becoming an OECM or another effective area-based conservation measure. Delhi has got, Gurgaon got its first OECM, basically a restored quarry area which was made into a biodiversity park. Delhi has shown the way in terms of biodiversity parks in the degraded Yamuna floodplain. They are doing very well in terms of as a good start. Maybe it will take a couple of more decades to really change the situation, but they are ahead in some ways. And I think Bengaluru, with its water bodies and green spaces, can avail of this OECM category. And that is another way of attracting capital, financial support, technical support for maintaining our green and blue infrastructure. So when we talk about integrated water management, all the other things that other experts here have shown, groundwater, surface water, we also have to think about the green water, which is basically the water required for the green and blue spaces in Bengaluru to help cool the city in the coming decades. That is a very important service. Otherwise, life is going to become quite difficult for us in the summers. So this is I just wanted to add this aspect to the rest of the discussions. And I'm very happy to be here with all these experts, and I'm learning a lot from everybody here. Thank you.
Thank you, Jagdish sir, and thank you for the slide. I think it's very informative. A quick jump to Professor Sanjeev Sambandhan, who makes drinking water out of wastewater. Professor Sanjeev, could you just elaborate on what magic you do?
Sure. So firstly, thank you very much for this invitation. It's been fantastic hearing everybody who has spoken so far. And I think quite a few people have already hit upon this point that wastewater seems to be a very important resource that we need to utilize. Um, so, as a faculty at IISc, I also created a startup which focuses on wastewater treatment, but with a slightly different angle. I mean, it's not only for STPs in apartments, for example, but it's also for other sectors, for example, hospitals, wherein you have not only the regular domestic wastewater that's coming out, but you also have effluents from all the pharmaceutical products they use, etc. So because of these effluents, the actual STP that is based on a microbial system underperforms, or it sometimes doesn't work. So hospitals is one source of wastewater where there's not much done, because most of the hospitals, if you go around, you see that they use conventional STPs. Then if you go around to the electroplating industries around Bangalore and you see all the effluents coming out of industries, once again, traditional or what should I say, microbial systems will underperform because the kind of water that gets in will not have the right pH. It will be overdosed with chemicals, and it's basically not going to help sustain these microbes. And when it comes to apartments itself, you find that microbial systems will do a fantastic job, but many of the apartments, they have very poorly designed STPs, or the maintenance is very bad, because of which they again underperform. So what do we do about these systems? So this is where my startup sort of focuses on, and even my research sort of focuses on how to handle these small bits and segments so that whatever systems we have in place can perform at the optimum level. So there are a couple of approaches. The first is when it comes to STPs that are poorly designed or that are not very well maintained, we can consider a little product which is like a polishing unit, which sort of takes out whatever the microbial systems have done and sort of polishes it and gets it to CPCB norms for reuse or discharge. And one very good use case for wastewater is actually in toilet flushing itself. It is a small use case, but nevertheless, in very large apartments, it's very useful. That is one sector where people are not very averse to actually using the wastewater. The second is when it comes to hospitals and ETPs, we can consider package systems which can handle the ETP waste, which is not based on microbial operation, so that you can handle chemicals and pH and variations in throughput, shock loads, etc. So I've just asked Nidya, who's kindly shared a few slides. So here is some kind of a vision which we have realized through the company, which is extremely tiny package systems. And this can be packaged all the way up from 1 kiloliter per day capacity, that is for a single household, for example, all the way up to hundreds of kiloliters per day. So household or industry. Okay, so I'm including all these three sectors that I mentioned. So the vision here is at some point, we have appliances for everything. We have appliances for washing clothes. We have appliances for washing dishes, but something as critical as water, we are very dependent on the government and centralized facilities. So what can we do to sort of boost that? So if I can reuse my wastewater at source and maybe send a very small percentage out to a central STP or an ETP unit, then I'm sort of helping that unit perform better. So the idea is to see how far can we go with regards to deep decentralization. Okay, so here what I wanted to show today is a very small STP unit. It's a packaged unit. It's in fact designed to be the size of a washing machine. And on the next slide, there is a little video, which, if Nidya could kindly play, which is on the right side. So this video is taken on a cell phone, so forgive me for the aspect ratio. So this is basically black water from the IISc STP plant, which goes into this washing machine kind of unit. And the physics of treatment, you're kind enough to call it magic, but it's basically electrocoagulation. But we have modified it to an extent that this unit is running off a household power supply, right? It's running off a 220 volt 5 amp socket, consuming 2 amps. So it's very much like a computer kind of power supply, right? What a computer would demand. So, and the kind of maintenance that you need is some kind of a, little, just like AquaGuard does a little package or cartridge replacement, we will also do a small replacement, which is the electrodes. So this is what I wanted to highlight, that maybe addressing all three sectors using other technologies can sort of help the existing infrastructure. You don't need to completely replace the existing infrastructure. It can sort of aid it. It can assist it. And I think there is a lot of room for reusing wastewater in these areas. And one thing which the government could do is, just like how in case of solar energy, you have policies that provide incentive to customers who use solar energy. Could there be something done for wastewater? Let's say if apartments do a good job at treating wastewater, can there be some kind of an incentive given? Because most often what we have seen when we try to sell products to apartments, it gets stalled at the, what is the right word? The association, the residents association, right? So by the time they decide on whether they want to go with the solution or not, the chairman of the association changes and nothing really moves. So if there is an actual financial incentive, just like in the case of solar, if there could be something done that would benefit both the technology providers as well as the users. Okay, so I will just leave with these comments and with a bit of brief on what we have done so far.
Yeah, pardon. I want to get the clarification with
Yes,
Sanjay Sambandhan.
Yes.
Yeah. So this particular technology, may I know your introduction, because I was not aware. We are from IIC or from outside.
Yes. I'm a professor at IIC. My background is electrical engineering, so I'm a little short. I'm little short-handed in the presence of all experts in wastewater. But over the years, I have learned my bit, and we have this startup from my lab, which has now become a full-fledged company, which is called Open Water. And we build packaged products for ETPs as well as STPs. So that is what those are the products developed by the company.
Now, do you have the capacity to scale up, or you want some kind of support from the government?
No. We have investors. We have funding. We are actually offering commercial products to many areas, but we would definitely, when it comes to STP treatment or leachate contaminated landfills, we would really appreciate the government can firstly point us to the problem and see if they can help us enable these solutions. Financial assistance is probably not needed. It's more logistic support and pointing us to the right problem so that we can diffuse this technology out and make an impact.
So basically, you're doing electrocoagulation cycle.
Electrocoagulation, yes. So
what about the cost factor involving this technology?
Yeah.
For 1,000 liter, how much will be the cost of treatment actually?
Yeah, so we do about 20 rupees per kiloliter when it comes to domestic sewage. And for ETPs, depending on the kind of ETP, it's roughly about 35 to 40 rupees a kiloliter. That's the typical cost of treatment for this. This includes electricity, electrodes, everything.
So have you done anywhere in the city?
Yeah, we have deployed 2 units in Tamil Nadu for ETPs. One is in fact in NLCIL. For in the city, we have one plant sitting in at Mavalipura, the landfill, the leachate contaminated landfill at Mavalipura. So we have a groundwater treatment system. But in any apartment, we have not really approached apartments because we have not made any headway because of the problems I mentioned. I mean, they all appreciate the water coming out and everything, but it's never translated to a commercial system in any apartment anywhere. But okay, ETPs, yes, ETPs definitely.
We need to discuss in elaborate. So
sure.
I will get your contact from the organizing this seminar. You are based out of Bengaluru, I hope so.
Yes, I'm from Bangalore. I'm a professor at IISc.
Yeah. No problem. We will have a one-to-one discussion on this aspect so that furthermore administrative details can be taken. How to scale up this operation, how to facilitate this operation. We'll have a separate discussion. I would request the moderator to connect to Mr. Sanjay for further cooperation. Thank you.
Thank you very much. Yeah, I'll be happy to discuss. Yes,
quick
yes.
Question. What is the capacity of the distributed STP or ETP rather?
So far the largest capacity ETP we have done is 100 KLD. There is no limit to scaling up. We can put multiple modules of 100 KLD and so on. And the way this 100 KLD looks, the kind of square footage it takes up is about 360 to 400 square foot. That is the kind of package that would go into any site for a 100 KLD unit.
Thank you so much, Professor. We'll connect.
Sure, thank you.
The PWSSB
Yeah.
also.
Thank you very much for this opportunity. Yeah.
Thank you. We have, I think we have run the course on the wastewater usage. I would, Swapnil and Srinath, I'd come back to you under the innovator, innovator discussion, right? I'm just quickly jumping to the runoff that happens. I mean, in spite of bountiful rains, 50% of the water is a runoff, right? But what happens is that apparently the lakes that are already filled with treated wastewater and untreated industrial effluents, etc., does not have the capacity to absorb the rain runoff, right? So so actually we are creating a double whammy for ourselves. One, the lakes are not being able to absorb the rainwater, and hence that causes flooding. And second, the lakes are full of treated wastewater and industrial water, which is not good for the ecosystem there. So I would like to request Ramanoji on two things. One is that who actually maintains the lakes and how do we overcome the jurisdictional confusion? Is there something that you could throw light on?
It's a paradox which is unsolvable. Right now, Bengaluru Water Supply Sewage Board is primarily responsible for water supply and UGD management. Actually, it should have been a Bengaluru Water Supply and Drainage Board, not a sewage board, so that the lakes and stormwater drain will be coming under the BWSSB, because these stormwater drain and lakes are critical for the overall maintenance of the water ecosystem in the city. But it is a policy level decision to be taken at the government level. So therefore, the lake rejuvenation or lake refilling or stormwater maintenance, which are critical for preventing water pollution, all those aspects are with the PBMP. Therefore, even if I want to recharge the lake, I have to get the permission from the PBMP or the BDA, which is other owner of some of the lakes. 5 lakes in eastern part of the Bengaluru, Varturu and Bellandur lakes, which is critically affected area, that belongs to BDA. So we are unable to desilt it and do the proper refilling of treated water. Therefore, these is the various other bodies are involved in the lakes. Some of the lakes are with the mine irrigation department. Some of the lakes are with the revenue department. So we need to have a comprehensive lake management authority, which may be working under the BWSSB or working with the BWSSB or as an independent body. But overall, there is a lot of discussion is happening, but so far there is no clear-cut policy decision on this issue. So that's why we are handicapped in this issue. In fact, I have discussed with IIC professors. They told that non-chemical, non-biological, only physical method of treatment is possible along the stormwater drain to treat the sewage which is flowing down in the stormwater drain to convert 95% as treated water. So that's what have been discussed and the technologies have been developed. But unfortunately, I have no administrative control or access to this stormwater drain and lakes. So that is a kind of paradox. So let us see how far we can able to solve these paradox in coming future.
Thank you so much. Thanks for the very candid answer. Ramchandra sir, is it somewhere? Is it possible?
Yeah, in fact, before you ask the next part, I have some this one. See, you talked about flooding in the city. Flooding is the cause of the removal of interconnectivity among the lake. You know, the encroachment of stormwater drain and lake bed is the root cause for the flooding in the region. And apart from that, You know, these drains have been narrowed and concretized in the name of remodeling. You know, for example, the drain which is between Agara and Bengaluru Lake, as per the historical record, the width of the drain was 60 to 80 meter. Today, in the name of remodeling, it is narrowed down to 18.5 meter. When they narrowed down the drain, you know, the very next year, 2020, there was a flooding in the region. Then when Koramangala got flooded, Koramangala residents were agitated. Then the BBMP came up with another ad hoc measure of creating one more drain parallel to this earlier drain, which was narrowed down. See, this kind of unscientific intervention by some of the agencies is the root cause of the problem. Now, coming to the water harvesting in lakes, I have done the quantification of the storage capacity of the lake. You know, the way back in 1800, we had 1,452 water body. The storage capacity at that time was 35 TMC, which could handle the flooding as well as the requirement of the city, the region for irrigation, etc. Now, because the lakes are silted, you know, the water storage capacity in the lake has come down. It is not filling the lake with the treated water or the untreated wastewater. It is the silt that is there in the lake. See, when we remove the silt from the Saraki lake, two things happen. One is the groundwater recharge happened. There's an adequate storage for the water, rainwater, as well as the treated wastewater. You know, that is the model to be replicated in all wards in the city. If you want to address the problem of the water in the region, you know, we have 193 lakes in the city, 198 wards. The model what we did at Jakkur Lake, nature-based solution with constructed wetland and algal pond will solve the wastewater entering the lake. Second thing is the rainwater harvesting should happen in the lake. For that, rejuvenation of the lake has to be done, and we need to do the desilting of the lake. You know, that silt is rich in nutrient. When we desilted Vartur Lake, you know, we gave that 400 acres farmer the silt. You know, when I visited those farmers within 4 months, they had, each one of them told me they got the additional revenue of 1.5 lakh per acre. You know, that is the kind of the resource we have. And other thing is the BWSSB chairman is here. I urge him not to allow the untreated sewage entering the lake. He has no right to send the untreated sewage through the stormwater network to the thing. He has to use his own UGDs and come up with the proper mechanism so that our lakes are not polluted because of the untreated sewage. If we want to leave the treated sewage, then JACO model has to be implemented in all the lakes so that we will have the enough water. You know, 15 TMC because of rainwater and 16 TMC because of the wastewater treatment, similar to Jakkur model. 31 TMC of water we have in the city. But because of the mismanagement, we are facing the water crisis. See, if we can rejuvenate the lake, the groundwater recharge happens, and our problem of the groundwater crisis also, we can remove that. So that is what has to happen. And there are too many organizations. That is also the problem, as the chairman of BWSSB talked about it. I know how the BBMP is mismanaging the drains in the city. You know, every time when floods happen, the government will sanction the big amount of money. This is being mismanaged, and they are fooling the system with all kinds of illogical designs. You know, that should come to an end. That is where we all have to work together to see that to ensure the water sustenance in the region. Okay. Yeah, now you can ask the question.
May just clarify, Professor Ramachandra ji, because right now BWSSB is always planning to use the treated water to fill the lakes. We are also aware that the consequences of sewage being entered into in the drains, entering into the lakes. So therefore, our plan of putting the treated water into the lakes, which are already being desilted. Of course, we thought some immediate solutions of filling the Vartur Lake and Bengaluru Lake, which is partially desilted. But after your observation, we have not done that because that will take some more time. But unfortunately, the major problem of the city in the eastern portion is due to the desilting was delayed in Vartur and Bengaluru. But I don't know. That was a major cause. However, to our model, we will follow the Agaram and Sarangi Lake model only, Jakkur Lake model only. And we appreciate the efforts of our scientific community coming out with the solutions. But we are always conscious and mindful of not letting the sewage into the lakes. But whatever the sewage which is flowing in to the lakes, that diverted and treated in the STPs in the near future. But however, our effort is only to fill the lakes with the treated water. Thank you.
Oh, thank you. Thank you very much for this intervention. And there's a hope in the system. You know, your suggestion of bringing the drains under BWSSB is a very reasonable one. I think we all should work towards and convince the government to make that. And make sure that the lakes are with one agency, not too many agencies, like as you rightly pointed out, BBMP, BDA, and all the agencies. Let us also work towards that. When all of us work together, certainly we can see the solution happening in the system. And earlier we had succeeded. That's what the beauty of Bangalore is, and we should make that to happen now also.
Ravi, I would like to add one point only.
Observation.
Mohan Kumar here,
With
Ravi.
respect to this,
Yeah,
no,
Chairman,
one,
sir.
just
Go
one
ahead.
submission.
Go ahead, sir. Go ahead, sir. Chairman,
Professor, yeah. One more observation which I observed, the stormwater drain, what Professor Ramachandra was mentioning, is very apt because narrowing down the canals is a major cause of choking of this water system. Secondly, concretizing the surface. We can understand the walls, but the surface being concretized will increase the flow rate. And also it will prevent the natural treatment of any wastewater which is flowing in the stormwater drain. Though the stormwater drain is not meant for that, but unfortunately, over a period of time, we have let that as a sewage flowing channel. But BWSSB the work to see that no sewage into the stormwater drainage. That is the ultimate vision on which we are working. Though I know that it is a very difficult and challenging vision. Zero sewage into the stormwater drain. That is our ideal motto, which we are embarking upon with the advanced technology and mapping of the system. But still then that unscientific lining of the stormwater drain and narrowing of the stormwater drain has led to flood kind of situation. And also the quick solution of lake being polluted with the sewage has been diversion channel. Unfortunately, this diversion channel become a suicidal attempt of the lakes. What I can say, in the rain time also this diversion channel is working. So the good quality water also not going into the lakes. That's why many part of the lake, many part of the city which is having lakes with a diversion channel due to improper maintenance of diversion channel or not timely operation of the authorities by the of rain, so that the rainwater is also not flowing inside the lakes. So this needs to comprehensive planning. Of course, I am also part of the problem or part of the authorities, but unfortunately, our hands are tied up due to our own jurisdictional issues. But still, we are hopeful with the scientific and knowledge community and other citizen forum to see that the policy decision is taken in favor of comprehensive management of water bodies, including the stormwater drain. Thank you.
Ravi, can I come in for one or two quick points? Yeah, thank you. No, one of the reasons for all these things is though the sewer connections, everything is given, still, even in our own setup at many, many places, especially low income group, whatever the areas, there is unauthorized disposal of sewage into the stormwater drains. Okay. And in fact, even to the extent I can even say in some of the things, authorized, even some apartments, things like that, which has been plugged now, that probably we need to really look at so that that is not done. The other thing I entirely agree with Ramchandra also what I was talking about. In fact, we also put up at several things where it should be one organization which will control the water in the city, including the stormwater drain is controlled by BBMP. Water belongs to these people. Water belongs to, instead of that, one agency should control so that they have a better control. Of course, definitely, I can even very closely working with BWC, I can say right now they may or may not have the engineers to do that, but we need to create such a thing to look at the whole system from the way you bring in water right up to disposal into the tanks and elsewhere should be one agency, including the stormwater drains. Then only it will work. One agency should handle. And I think all the more, when you have one agency, you'll be in a better control of all these water systems, and you can do. One more small point, we always think we can do the recharge in natural system, everything in a big drain, Raja Canal, which we should do. We should also understand during floods, the type of water flows in all these tanks will be extremely high velocity, extremely high. So unless if it is not properly designed, there is a very, very high chances of the cavity occurring, and the structure itself may collapse. We have to be extremely careful in all this when we do. But the other point will be store this water to the nearest lake and then store it there, and also create drawdown condition in these lakes, Ravi. What you are talking about, we have, in fact, as a part of the urban flood project, Professor Mujumdar, myself, we have given a report also to the thing where we need to have half fill, half should be the local catchment. That's how all the tanks should be. Right now, it's all the fixed drawdown. There is no drawdown condition at all in all these lakes. There should be proper gate systems to work on it. All of us are agreeing how to harvest flood water, how to harvest treated water in our own area, then allow it to flow. Thank you.
Thank you so much, Professor Mohan. A quick question to, Professor Ramchandra, you, and of course the chairman of BWSB, is that the rainfall is extremely it's not uniform through the year, right? So between June and December, it's about 3 times the rainfall that happens during the drier months, and the consumption during drier months is more, and the availability of water is more than the consumption in the June to December period, right? So this cyclicality of rainfall needs us to create some kind of sponge cities, right, which can kind of absorb the moisture and keep it available throughout the year. What are some of the solutions that you would have to create such a kind of a sponge city?
Okay, see, this is a very good this one. What I said earlier is we should make the landscape porous. The term what you have used is a sponge. You can create a porous landscape through the vegetation cover as well as by desilting the lakes. If we do that, then the landscape becomes porous. My study shows that when a landscape is covered with a vegetation cover, 55 to 60% of the rainfall gets into the underground, to the groundwater, the aquifers, etc. That is what the water is available during the post-monsoon. The study done in Western Ghat as well as in Bangalore clearly shows that we need to have a vegetation cover to allow the groundwater recharge. And if we have a native species vegetation cover, the groundwater infiltration or the water getting into the water zone plus groundwater zone is as high as 55 to 60%. When we concretize, as it has happened in Bangalore, very unfortunately, we are allowing the zero water getting into the groundwater sources. That's where you have a large amount of water on the overland. And our conduit, these stormwater drains are blocked, or we have allowed people to encroach and dump the solid waste, construction, demolition, debris, etc. In the process, we have complicated the issue. That's where I've been insisting that we need to re-establish the interconnectivity among the lake so that water can move from one lake to the other lake. We should do the desilting of the lake and storage and have the mini forest in each ward. In addition to the, having a green barrier in the floodplains of the lake, that so-called buffer zone, we should not construct roads. Recently there was a meeting on Bangalore where illogical the suggestions have come to create the roads on the buffer zone of the lake, which is a disastrous. That is where we should assert and tell the government that this kind of illogical design cannot be implemented and should not be implemented in Bangalore, city like Bangalore. So to minimize the problem of the water crisis as well as flooding in the region. So your suggestion of making the landscape porous or a sponge is certainly possible, provided we all join and create the mini forest in each ward and also take part in the rejuvenation of lake. The success of Saraki Lake or Jakkur Lake is because of the community. Community were active. The community participation decides the fate of the common lands, which include the open areas as well as the water bodies in the region. So since the people were quite aggressive in the Saraki Lake or Jakkur Lake, they could get what they wanted. Today they have the water in their well. Whereas the other part of the city where people are not taking care of the lake, they are facing the water crisis. Okay.
Thank you. Quickly coming to the rainwater harvesting and groundwater, as one of the important conservation methodologies. Can I call Satish Malia sir to help us understand how to encourage rainwater harvesting in residential complexes? Is it possible? Can we do it? Because out of the 1800 MLD that is harvested in Bangalore, only 32 is used is about 800 mld of rainfall that happens, only 32 mld is harvested, right? So is there something that we can do with the residential complexes? Satish, Arun?
Are you able to hear me?
Yes, we can.
Yeah, hi, this is Arun Kumar. On rainwater harvesting, just before that, I just wanted to mention a couple of other things with your permission. During this shortage, we've created enormous amount of water as awareness campaigns across the entire apartment network that we have, and it is reaching about 1.5 million residents who are residing in our BAF member communities. And we've got multi-pronged communication and awareness. One is as an individual what you can do, and as a community what you can do, and it has gained a lot of adoption, and a lot of progress is being made. And we are actively collaborating with multiple partners. BWSSB has been very supportive, and we have been extensively cooperating with BWSSB, and of course with partners like Well Labs and KSCSC also we've been talking to, TREDI also we've been talking to. One of the reasons rainwater harvesting is a little low, Ravi, is I think one of the mention was about design and operation on the subject of SCP. Same is the case for rainwater harvesting. The design, the quantum of collection, the sumps, etc., are very poorly designed in the beginning itself by the builder, and we are constrained by that. In addition to that, the extent of awareness of rainwater harvesting has been inadequate. The campaigns, the awareness have been not very great. So those are two issues specifically that we see, because of which rainwater harvesting has not garnered enough attention. But we as the BAF have been communicating this for the past many years, that prior to the rainy season, please make sure that all your drains, all your pathways, water pathways, etc., are all cleared of debris, of chokes, etc. And some of them do, some of them don't. We believe at this point in time, which we are talking to KSCSC, is putting in place a project team to make sure that we go across all the individual communities to make sure that whatever rainwater harvesting systems are in place, at least those are made properly functional. Where there isn't, identify projects and create project reports to make sure that we put in rainwater harvesting systems in place. And we have been talking about this with various partners, and academia is more than welcome. We would like to partner to see how we can make rapid progress on the rainwater harvesting also. The intent is there, but at the end of the day, there was another mention about capital investment. So we need to make sure that apartments put in the additional capital investment to make sure that these rainwater harvesting as well as the groundwater recharge systems are put in place, and whatever are in place are properly functional and operating on an ongoing basis. And just to digress and go on to another subject that was extensively discussed, we as apartment communities were, net water consumers always. Obviously, we were consuming waters, but very happy that, the enormous effort we've been putting over the past 2, 3, 4 years has resulted in the policy on treated used water. And because of that, there is a lot of interest in selling treated water from the apartment communities. The maximum penetration of SCPs anywhere in India in residential communities happen to be in Bangalore, and people are again putting in time, effort, energy to set right any
gaps in the STP infrastructure to make it better quality, to make it sellable quality. So that is another input I wanted to give to this meeting. If there are methods on improving quality of testing of treated water, we are more than welcome to use those. And we are always into amplifying the importance of using treated used water. And we want to amplify the uh, the aspect of taking it further into tertiary treated water. I think Priyanka was mentioning about, and Sir Ravi was mentioning about the stigma behind used water. We are doing a lot of efforts on that also, and trying to make sure that people progress from what their current mindset is. And there are a few apartment communities which are drinking, the tertiary treated water. Some of them are using it in swimming pools. We hope to, we wish, and we want to promote more and more such adoption across the city. And it will become a reality sooner than later. And each of you, I request you also uh, to amplify that more than the stigma aspect, that, please amplify that, there are uh, apartments which are using treated used water for near human consumption or actual human consumption purpose. Back to you, Ravi.
I just want to come in. Sorry,
Yes.
I could not unmute it. Okay. I think most of the points Arun has spoke about it. Two points. See, regarding the rainwater harvesting, the act from BWC has come way back in 2009, again amended in 2021. So almost 15 years. Either be the government side or the community side, we are not able to encourage people to put in place this rainwater harvesting. I think lot of things has to be happened, awareness. I think now community aware of it, saying that what are the benefit of having a rainwater harvesting wells and other things. But from BAF side, we want to promote open wells now, because see now in closed rainwater harvesting, people are not aware because building was handed over by the builders, and there is no rule now also saying that for a particular 1 acre or 2 acre land, how many rainwater harvesting pit is required. Law says that only 2,400 and above you should have a rainwater harvesting pit. So a lot of things work in progress with the government agency, and BWSSB is helping us. Like I think after discussion, chairman has come out with a 5-star challenge. In that, one of the point for getting a recognition for apartment is that if you have a bore well, you should have a 2 numbers of rainwater harvesting pit. I think it's a good initiative for awareness. I think it's will appreciated by our community. And second thing, open well, why is required? Like the people can see that water in the open well, and from there you can pump it to this thing instead of going this thing. So we want to promote that open well and going forward. And we are also working with KSCST, which Arun was talking about. But another point what I want to talk about is everybody talking about waste. I request the scientific community and others to talk about treated used water instead of treated wastewater. This is one of the initiative we have taken in 2019, writing to Niti Aayog, saying that let's not call it wastewater because nothing is waste. And if you call it waste, people are not able to, not willing to use it further, to reuse it further. So I request all the technical or scientific community to term this as a treated used water, and always BAF is promoting that way only. And Niti Aayog has appreciate us saying that in future draft policy also they mention as treated used water. Thank you so much.
No, Satish, thank you very much. With the permission of the chair, in fact, in the vision document of BWSSB, it is called used water. CS2M Hill, this advice of BWSS prepared this. As you rightly said, it is called used water. In fact, thank you for clarifying. Thank you.
Thank you.
Thank you, sir. Satish sir and Arun sir. Do we have
Ravi, I
yeah.
just want to mention one other thing, small thing, but very important thing. Apartments have been in the forefront of reusing STP treated water, whether it is flushing, dual flushing. Many apartments a lot of apartments are using flushing toilets using reused water, gardening extensively, and with this current situation, car wash, etc., in the basement or common areas, all happening with HCP treated water. So we are taking a lot of efforts, initiatives to make sure that we put good use to treated used water.
No, absolutely. Treated used water, water usage has been it's increased dramatically. The only concern that was, unlike a Chennai, we don't have rainwater harvesting as a culture. So maybe we need to work harder on that point. Is what the discussion was about. It's great to hear that the BAF is pushing this very hard, and I'm sure the target that we're looking at is out of 32 MLD out of being harvested, maybe we can look at about 100 MLD end of this year. That would be wonderful. Quickly coming to Mr. Shivakumar, can you throw some light on how rainwater harvesting and groundwater saving can be done? What steps are as this case is still taking for this?
Thank you, Ravi. In fact, the lot of things have been told about how the popularization has taken place in rainwater harvesting. In fact, in the country, we should see that the BWSSP and KSCST in Indian Institute of Science collaboration stood as a model way back in early 2000s. And then we came forward. We created that rainwater harvesting theme park, which has been replicated now elsewhere like Hyderabad, Jubilee Hills, and Kanpur, Bhubaneswar, and all that. We have walked several miles in such kind of initiatives. We have trained more than 2,500 plumbing contractors, architects, and others. They are available in all 200 plus wards of Bangalore. Now, coming back to the subject which has been given to me, groundwater, especially to see that we have the right word, what you have used is a porous. I call this as a porous city concept. A lot has been spoken about the lakes and other things, which is the last portion in this porous city concept. Let me tell you how it starts. Groundwater is a common natural resource, and no individual or institutions owns it. So we should see that for good, common good, this has to be well protected, and how we use this. It's a magic number or a guesswork or a number of bore wells, how much groundwater is being pumped in the city, and total number of bore wells in the city. Nobody has the exact number. City water uses need to be accounted from all sources, including bore well, tanker supplies, install meters for all the bore wells, both public and private. Very, very important. Otherwise, you will never know how much water has been used. BWSSP is one institution in our country which has majority of its supply metered and accounted for, and also of very high quality. We should appreciate how BWSSP has become a model in the entire country to see that metered water supply, which has gone accurate to the subdivisional levels, and then they have pinpointed where the leakages and other things are there. Number of metered connections also is the highest in the city, in the country. We can see Bangalore has shown a way, and this is a revenue model which has been very well demonstrated. Now, coming into harvesting of rainwater, harvested rainwater store and reuse is the best concept. Like most of the apartments and individuals, we should be very happy that nearly 200,000 installations, homes and buildings have rainwater harvesting in Bangalore, which is a very good number to start with. You see, though the water supply is more than 100 years in the piped water supply for the city, rainwater harvesting was only less than 2 decades where the people started talking about, and we have achieved. There are so much of things have been talked, and there are so many institutions which are doing rainwater harvesting. Harvest rainwater, store it and use. Bangalore is designed to see that you store water and use. And at the same time, Bangalore is heavily dependent on groundwater also. Next to Kaveri water, the groundwater is the source which gives a lot of emphasis to see that how we handle that. Every building, whether it's domestic, institutional, commercial, should have percolation pits or cement ring wells, depending on the size of the roof and catchment. This is basically just a 3 feet diameters cement rings around 15 to 20 feet deep, and nothing should be filled inside that. Allow your rainwater to go into that. That's all is required. The overflow of that rainwater harvesting sump need to be channeled to the borewells. There are nearly 50% of the borewells in the city are dry and they are dead. Why can't we revive them? We have shown in our BWSSP rainwater harvesting theme park how we can revive those dead borewells by diverting this excess rainwater after filtration into these borewells, and the same aquifers which have gone empty have started yielding back. Stormwater drains. Let us start with the house and then go slightly outside. Stormwater drains in residential layouts should have percolation trenches, and this is now has become a law. Unfortunately, only in the new layouts it has been written, but I don't know where all it has been implemented. Every 50 meters in the stormwater drain in front of the homes and the sites, we should have a percolation pit so that the rainwater from the road and excess water from the buildings can percolate into the ground. Bangalore has over 12,000 kilometers of paved roads, tarred concrete. Can you imagine? I was surprised to know this kind of figures. 12,000 kilometers. Paved footpaths should be laid with perforated pavements. There are enough examples which I have shown in our theme park, in our Indian Institute of Science campus, and various other institutions, including in Infosys as well as the airports and all, where these pavers can have holes or the porosity so that the rainwater can percolate and recharge into the ground. Imagine 12,000 kilometers and how much footpath we have. Why should we have concrete on all this? No doubt, these roads can be tarred and concreted. Why not these footpaths percolation pavers so that the rainwater percolates into that? All playgrounds and public parks should have accelerated recharge wells for groundwater recharge. They have become good catchments to see that the local area and groundwater is recharged. Large vehicle parking areas to have perforated pavers and also accelerated recharge wells. And finally, coming to the lakes and water bodies to have deep aquifer recharge shafts on the peripheral areas. See, this is also very important to see that when we highly depend on groundwater, why not see that it has been projected and then well done to see that we have very good groundwater system maintained and monitored. For example, you see there was a debate who monitors water supply in Bangalore. There are several agencies. It's not only BWSSP. Come to these RO plants. RO plants have been banned by WHO and various other cities, including Delhi. Left and right in our Bangalore city, these RO plants have come up in almost every wards. What are they doing? They pump out water from the ground, treat it, and most of the reject just goes back to the ground there. And even after a higher concentration because of evaporation and all that. Why not these RO plants be supplied with Kaveri water? The quality of water BWC supplies is no less or even better than those RO plants which I have seen. Why not just plug it and then supply? And it's around more than 250 to 300 rupees per kiloliter of treated RO water which has been dispensed. And only these like elected people's photographs and other things are trying to promote this. Why harvest groundwater for this and waste water after the rejection from the RO plants? Why not BWSSP supply all these? Just connect to these RO plants which are dispensers, the coin dispensers, what we have, the water ATMs they call, with the Kaveri water, and then see groundwater is used elsewhere for better purposes. This is how a city can have a porous city concept from the house, footpaths, stormwater drains, playgrounds, and to the lakes. We should have a systematic plan to see that the runoff is reduced and finally it reaches lake after saturation of the subsoil water as well as the deeper aquifers. Thank you.
Thank you so much, Kumar. Professor Shekhar, for that, Professor Alan Rao, your hand is up. Is there something you would like to share? Professor Rao?
Yeah, a couple of points I thought I would share. So some of the interventions we have done and some of the data we have, I thought we would share. I will take about 2-3 minutes. I'd like to start off with some quick positive note. So we have been involved with two agencies. One is the Bangalore International Airport. The other one is a apartment real estate developer called Good Earth. So in the last 15 days, we visited them. We have given them complete water treatment management solutions, me and my team with other professors from ISC. Happy to say that both of them are water positive. So they have excess water on their campuses, and now they are having, they're sitting comfortably. One has more water, so he has a flooding issue actually. So his water is coming up. So anyway, so with that positive note, I would like to bring upon a couple of things that has to be clarified, I thought, during all these discussions. In this concept of water reuse and the wastewater, or the stigma of not using the wastewater, one of the concepts is to separate out gray water and black water separately and treat them separately, and then allow two different streams of water available for reuse. So this way your acceptability of treated gray water becomes a lot higher, even if it is watering your tulsi plant to using it for your all other purposes. It becomes a lot easier, and it is lot more acceptable. Your water quality also very high. You don't have to worry about pathogens. We don't have to worry about all other crap which will come with your black water. Okay, so in water reuse. So this is the concept which was adopted by Good Earth, which is there in Bangalore, and their treatment cost of water has come down by nearly 1/3 of what it was before. It was for a 110 KLD apartment complex, which they have built, and they are successfully running it over the past year and a half now, where they separate black water from gray water. That was technology developed by our group. Second, we also have technologies for inline wastewater treatment, which chairman sir also mentioned. So wherein we can remove 90-95% of the wastewater. And when we talk about wastewater, I think there is also a stigma of heavy metals coming into this and some kind of contaminations. For the past 5 years, we are looking for heavy metals in wastewater. We have not found one. And this wastewater, because of the H2S it produces, it will not have heavy metals in the water. It will deposit back into the soil, and the soil might have sludge, might have heavy metals. This is what we have found in our research over the past 5 years. So all the wastewaters which are entering all the STPs itself does not have heavy metals coming in, and so that worry doesn't have to be there. A lot of scientific data has been generated on this, and a couple of publications also have come in on this aspect as well. I agree that for a city like Bangalore, a couple of things which is very much needed is we should separate out stormwater drains from the wastewater drains. That's a very, very important thing. It gets mixed, and that is not very ideal. Lakes should not receive untreated wastewater. It has to be all collected, treated, and sold. All construction purposes, there is policy for using of treated wastewater, but that's not practically followed. There is still a big gap. For a city like Bangalore, all the apartment complexes, though they have STPs, I have visited in the last 1 month, maybe some 50 STPs at different apartment complexes. None of them are working. They're being extremely poorly managed, and the STPs are not working properly. The treated wastewater is not being used properly, so there's poor maintenance. So clearly there has to be some points to be made to make up this STPs working properly, and you have this availability of water available on you so that you can use it. So these are some of the points that I thought we should bring it in to the, for all the audience here. Thank you, Ravi.
No, Professor Rao, just as since you're already on the topic, would you also be able to expand on the, the wastewater treatment technology that you have been using so well? Maybe a few minutes on that.
Yeah. One is for the nalas that we have developed, and this came about from one of my PhD students who worked on it. So this is for wastewater carrying nalas. Again, it's a nature-based technology. We don't add any. We believe in a concept that wastewater has enough chemicals in it, so you don't need to add any more chemicals to get your wastewater to work. So without any addition of chemicals, using our year-old or age-old anaerobic sludge blanket bioreactor, we can achieve up to, coupled with some aeration, we could achieve up to 90 to 95% of nutrient removal in this wastewater. So this can be done in nalas. A concept has been proposed to the city and the city is looking at it. So that is one concept for the nalas where wastewater becomes, wastewater can be treated. The second concept we have developed and demonstrated, it is currently running in Bangalore, is the decentralized wastewater treatment system for an apartment complex where we separate out black water and gray water and they are treated separately. So black water doesn't get mixed with your gray water. The quality of the black water and the treated gray water is very high. You don't have to worry about all these pathogens and all this, other crap which comes with the black water. So the worries of black water and the stigma of not able to use or reuse this treated wastewater because it is mixed with your shit and urine is not there. And so people are more open to use this for this water. Because you also separate out gray water and black water, your nutrient load also gets split. Your nutrient is not getting diluted. Your treatment cost will come down significantly. So up to 1/3 of treatment cost will come down. So this is what is the concept. It is running right now in Good Earth. So people are happy to, I welcome you to go and see it. For the past 1 year, it is running. So that's the central concept. The concept in the Nala system used to use a combination of upwelling sludge blanket bioreactor coupled with aeration, natural aeration. In apartment complexes, separate gray water and black water separate, and then treat it separately. So this is also another concept.
Thank you, Professor. Quickly, just a couple of points left in the groundwater and rainwater harvesting topic. Just couple of questions. One is to Sucheta from the Central Groundwater team. What exactly are the best practices that you think we should adopt to save groundwater, Sucheta?
Hello, sir. So when we speak of in terms of groundwater, what we do at the Central Groundwater Board level is we always go for monitoring and management of the groundwater. And regarding monitoring and management, what involved is regular manual water level monitoring, which CGWB had been carrying out for so long. But now under National Hydrology Project, we have started with installation of the DWLRs, that is digital water level recorders, with telemetry from which we are receiving high frequency data. So this has already been implemented for the city of Bangalore as well as for entire Karnataka. And we are in the process of increasing the number of DWLRs with telemetry system for the entire city as well as for the entire state of Karnataka. And because without the monitoring, there can be no management, because we'll not get to know how much water level is going to decline in terms of like the climate change, which has happened just now with very deficient rainfall. So this has been one very important step that CGWB has been harping on. Moreover, the defunct wells which are present under various agencies. So for that also CGWB is looking into getting the details of all those defunct wells and to check out whether they can be used for recharge as well as for monitoring in the long-term scenario, because these can be very useful in terms of helping with the groundwater rejuvenation also, as well as for the idea of managing the resources. So these have been two important points with respect to CGWB. Other than that, what the board has always thought about is as rightly pointed out by the other speakers also, we harp on artificial recharge to the groundwater. And in city scenario, the rainwater harvesting has been very much focused upon, as well as for open areas that are present in the city. CGWB has done a study right now, it is continuing, that is the National Aquifer Mapping 2 study is going on.
In previous years, National Aquifer Mapping 1 had been carried out, where taluk-wise aquifer management plans had been prepared. And this year, that is 2023-24 and 24-25, we are focusing on the city specifically so that we can understand the nitty-gritty details of the aquifer, because without understanding that, any kind of planning for groundwater management will not be much effective. And in terms of planning for recharge as well, we need to know that what is the thickness of the desaturated weathered zone, the areas where the water level is shallow. We cannot say that the entire city is suitable for rainwater recharge or artificial recharge structures. That should also be site specific based on the hydrogeological conditions as well as the condition of the weathered zone, the soil type. These are the factors that we should always keep in mind before going in the general direction of recharge, as well as other factors of like lake rejuvenation and all those things.
So Sucheta, this DWLR data, it's been shared with which bodies of Bangalore? I mean, is the data actionable? And second, is it with which bodies has it been shared?
We are sharing the data with groundwater department and also now with IISc and BWSSB. Yesterday we had a meeting and some groundwater outlook scenario is being developed by the IISc and CGWB and BWSSB jointly for the coming years based on the water level monitoring network and maximizing the water level network stations across the city.
Wonderful. Is it possible that we get some results in this cycle of monsoons? Is it possible?
This cycle of monsoon, sir, we are just starting up right now, and we means the outlook part is being handled by IISc, and we will be providing some data on water levels also. So most probably it will get activated in 2 or 3 months, I think.
Thank you so much. Professor Shekhar, sorry, yeah, please go ahead.
And based on our regular water level observation network in the city, what we have observed is that this year, due to the deficit rainfall, the water levels in the November month, they should be shallower as compared to the May month water level, because the recharge will be taking place in the monsoon. But our observation in the 63 wells which we are monitoring for water levels has shown that the November water level and January water level is deeper than the May water level. That means the aquifer has been desaturated very much due to the non-recharge of the aquifer due to deficit rainfall. And this phenomena is more observed in the peripheral areas, where the water scarcity is more observed based on the groundwater level scenario.
Okay. Thank you. Thank you, CGWD. Can we have Professor Shekhar give his insights? Priyanka, you have a question?
Just wanted to raise a point like regarding the dual pipeline system Rao sir said. I totally agree with that. Regarding the question you had asked me earlier on the cultural acceptance. So like he mentioned, having sewage mixed with the grey water is the kind of issue with the acceptance. So if we have it separately, that would really help, and it would bring down the treatment cost, and the methodology would also change for the two methods. With regards to a tulsi plant, from long ago we would use cow dung or cow urine to make our soil more fertile. So I don't think that was an issue. But with regards to taking bath and things, that is when people think twice as to what kind of water they use. So a dual pipeline system, like sir mentioned, would be really helpful. So just wanted to give that
Ravi, can I add 1 or 2 points about groundwater? Shekhar is not there. He's going to do the project. Can I add 1 or 2? I heard the CWB expert, having spent all my time in groundwater, in fact, 30, 40 years in groundwater. Vishwanath is also there. See, one of the things in Bangalore, what we should really understand is that the top weathered portion we have, okay, then the shallow portion, what we call shallow aquifer, then the deeper fractured rock, which is there. The deeper portion recharge is very, very difficult, very slow rate. The shallow one we can do to some extent. In fact, the overall recharge rates in Bangalore, which has been studied by Subhash Chandra, very many people, is anywhere from 3 to 6%, not more than that of the rainfall. And the whatever the CGWB was observing, when you carefully see what they were talking about, they should have had the November water level much higher, of course, with respect to groundwater in the lower. The fact that it's going down indicates that proper recharge, as he rightly said, is not taking place. Over extraction of groundwater is taking place in those areas, especially the peripheral areas. So more and more apartments, without having a control on the what they can draw from each of the regions, if they start drawing more and more, and obviously it's going to, the water level is going to go down, which it's showing actually. The way now what IAC is planning, along with, of course, CGWB monitoring, they will also exactly know what to draw, what not to draw, when to stop, when enough is enough, I can't draw anything more, or how I should recharge it using the treated water, how much I should balance locally is very, very important. Many things are, though all these groundwater things are all connected, still quite a bit is a local phenomena. Lot of granularity is there. What happens in some portion may not happen in the other portion. A lot of changes in the geology strata. I think all that what IAS is planning along with CWB will be extremely useful. And I think the way the signals are showing is a little alarming. And more so, many of the tanks in the eastern Bangalore was emptied for whatever reason, desilting and other things. That really showed the effect on the deeper aquifers being literally empty, which is a very, very scary portion, but we need to really fight back and get it back into the circulation. Thank you.
Can I just make a point, Mr. Ravi? Sorry, I just couldn't resist because rainwater harvesting is being talked about as well as wastewater. One of the things that we're doing is that the bylaw is very clear in Bangalore. It says that every plot is responsible for the rainwater. In farmland, we have a concept of 5% area, that if you devote 5% of area in semi-arid India for a farm pond, then you can be more water secure. Similarly, in cities, if you devote 0.5% of your plot area, 0.5%, you can make a recharge well, and every building can harvest rainwater and push it into either the tank or into the recharge well. We have a goal called the Million Wells for Bangalore, be from Biome Trust with the weldingers, traditional welding community. And wherever we've done it in a cluster, we've seen that there's an immediate difference in the sub-aquifer, in that micro-aquifer. One of the points that has to go with rainwater harvesting, which gated communities can do and the BF can help, is the communitization of bore wells. If you imagine a layout with 360 sites, what happens in Bangalore is all 360 drill bore wells. All 360 are competing with each other to empty the aquifer very quickly. But if the gated community can only put 3 bore wells or 4 bore wells, common bore wells, but make 360 to recharge the aquifer, then they're on the path to sustainability. So it's not merely rainwater harvesting and recharge, but also demand management and how do we communitize groundwater. And that also includes metering and pricing. Without pricing, you can't send signals of conservation of water. These have been tried out at many gated communities. Rainwater harvesting in compilation, in compendium with groundwater extraction simultaneously. And that can be replicated very quickly and it bears benefit to the community at large. The point about wastewater or treated used water is that if you want to remove the yuck factor, you need to put the treated used water into lakes, dilute it with rainwater, allow it to recharge into the aquifer, into the shallow aquifer, pick it up from open wells, put in place a state-of-the-art water treatment plant, and then supply it to the domestic network, meeting BIS 10500 drinking water norms. One of the first project of its kind in India has been done in Devanhalli. We've been doing it in other parts, like in Sonapnalli and Hunsamarnalli, town municipal councils on the periphery of Bangalore. And we find that some of these lakes are capable of recharging the shallow aquifer, which you can pick up from what are called filter bore wells. These are shallow bore wells, which are only 80 to 100 feet deep. You can check the water quality, set up an adequate water treatment plant and distribute it. No yuck factor, no tulsi plant factor, nothing at all, because it goes into the domestic supply indirectly. I think those examples are there. And we need to work co-jointly with all these forms of water: rainwater, lake water, treated use water, and groundwater, if we want sustainable solutions without the psychological barriers. They are the most cost-effective and the least energy-consuming waters also. So therefore, those benefits also are accrued.
Absolutely. Thank you, Shrad. Very lucid. We're quickly, Sahana, there is, you have done a lot of work on restoration of landscaping and, capacity building in the citizenry and the practitioners. Would you share some of your thoughts with us?
Yeah, thank you so much, sir. Would it be at all possible to share my screen for a minute? I just wanted to see if that's possible. And I'll start responding, and Nidya, when I get the option, I'll do. I think in everything that's been stated, it's very comprehensive and really quite fortunate to get an opportunity to speak here among all this eminent people already speaking. But I want to call back on one thing that Dr. Ramchandra had spoken of right at the beginning in terms of the factor that real estate development is actually a key driver of what is happening in our city, and the fact that it is quite extensively unmanaged. So while we talk of our blue-green network of consumption and demand management, the way our city is growing and continues to grow, I think that is a cause of concern. And at some point, we also need to factor that in terms of how we end up managing our blue-green networks or spaces and so on. Because it's not just the development, say, of commercial spaces or residential spaces, which is very extensive, but it's also the sort of infrastructure expansion that's happening in terms of, say, road networks and so on. I think Dr. Shiv Kumar also alluded to this. But let me just share one thing that that we have worked on that I think would be very relevant here. So this is from a report. I hope everyone's able to see my screen at this point. This is from a research piece that we had done, which was published last year, and it looked at Bangalore and 10 other cities across India between 2000 and 2015 to 17. And this is just understanding some things around how greening has been, or vegetation has changed across the city. So we see what is green is where we see moderate to high gains, and what's yellows and reds are where we are seeing losses. And there's a very distinct spatial component of where that's happening. And we know that, the peripheral areas is where a lot of new development, etc., has been happening. And that's where we see this sort of loss in green cover. But along with that, we were also trying to do a very rudimentary and high-level assessment of groundwater recharge potential. And I know we have a lot of hydrologists on this call, but please keep in mind, this is just looking at spatial data and trying to understand how, just demarcating what sort of potential recharge is available. So in 2000, we see the gray at the center, which was what was built up area at that point. And all of the rest of the area, study area of 50 kilometers that we had taken, we mapped out and said that this is what recharge potential might look like, where the darker greens are where you have high recharge, reds and yellows based on gradient or low vegetation cover have low recharge. So it's very granular, it's very basic, but it's a high level mapping. And of course, it needs much more ground truth information if we want to do actuals out of this, but it's indicative. So what we did after that is actually just overlay where new development has happened with what sort of recharge potential we had mapped. And what we see is that 64% of our new development has been on areas of high and very high recharge. So this is what really I want to call back on, that that where we are developing, because of a lack of guidance, regulation, enforcement, for multiple reasons really, is leading to this sort of challenge and issues that we have. So I think that is something we might want to keep in the background as we think on what we can do going ahead. So having said that, just to come back to the point, Dr. Teneti, that you had asked about of what we have been doing, I think one very interesting entry point that we have, not just for the water piece, but also around greening, because we do know that having green infrastructure, blue-green infrastructure is key to ensuring resilience and sort of adaptation to the climate risk that we are going to face. One entry point might be something that WRI has supported BBMP on recently, which is the Climate Action Plan. And that's very high level. It's at a city scale that we are looking looking at how does the city look at resilience going forward across different sectors of even mobility and so on. But urban planning and greening are a key component within this planning framework. And I want to call on some of the aspects that we talk of within this climate action plan, where we are talking of adoption of, say, nature-based solutions to improve resilience and livability. And I think this is what we need to do. And I think to a extent our whether it is for water resilience, improvement of our water catchment areas or greening, that has to be a little bit more strategic. Because the city is developed, we have a lot of built footprint. We can't go in and say that we will just remove areas where people are already living. We have to find ways to retrofit, and we have to be very strategic in where we say greening, etc., can happen. Again, Dr. Ramchandra had talked of, like high-level numbers, 2 hectares per ward. But do we actually have that sort of space in, say, inner city wards, which are very dense? And this is where I think we have to think of ways in which we draw from the local community, understand what their needs are and what are the biggest hazards they face, and therefore link our solutions of NBS or greening to those specific problems that we want to solve. I think a lot of times our interventions are just in terms of the greening, that we will plant so many saplings. But does it actually effectively help with recharge? Does it effectively help with flood control or with heat mitigation? I think linking it to those sort of outcomes and having the community be a part in developing these sort of final solutions that would be deployed at the ward scale, I think that's the missing piece in how implementation will happen. And I know the examples we have from the Apartment Federation is really good, because it's each community working together and coming at a sort of desired result. But I think we need to expand that at a ward scale, because we have a lot of areas where the ward itself has to start looking at improving its resilience and improving how it manages its common resources. We can't leave it that every individual at a property level will be able to do everything. Of course, everyone should have interventions, but how does it all come together to work as a unified whole? That happens either at a ward scale or at a zonal divisional scale. And I think those are the pathways that we have to look to. And maybe using the climate action plan as a basis for some of these actions might be a possible way that we can look at going ahead. So I would just pause on this, but just linking data to and having publicly accessible dashboards, I think that is also important. And making it useful for the community to take and understand and be part of solutioning, I think that is going to be very important in the future. We cannot just have, and while we need the science community to bring the sort of evidence and the framing, how it happens on ground really has to bring in all of the community and their perspectives, because at the end of the day, it's true that we don't have the experience that, say, an informal worker out in the city is facing. And that is something that they themselves will be able to think of and give suggestions for. So we have to find a way of bringing these together through various platforms, and therefore arrive at solutions that are not just from a city perspective, but for actual individuals in the city that work for them. So I would just submit on that. Thank you so much.
Wonderful words. Thank you, Sana. Dr. Maheshwari is there? Is she on the call from BBMP? Dr. Maheshwari, are you there? She's on hold. Okay. We wanted to. Professor Shekhar, you come back? I thought you were on the project.
Hello, how are you? Can you hear me?
Yes, we can. Please go ahead. I would need your thoughts on, how do we improve the groundwater usage, and how do we, monitor recharge of rainwater.
Oh, okay. So, thank you very much for having me in this. I heard several conversations on groundwater. I think the question which you framed, there is no silver bullet for this. So it's world over. The science on groundwater is developing. The science on groundwater recharge is still developing. It's not as that's why I said it's not there. So the thing which we should understand is there are a lot of myths in hydrology. They are getting changed with example. We assume that there is that with extreme events, what will happen to groundwater recharge? So there is possibility that you can have more groundwater recharge than runoff. We are now looking at various aspects. So in that sense, what probably one of the major issues which I see is that we are looking collectively the groundwater without much information. As I can see, the groundwater development has happened in Bangalore, elsewhere, whole India as such. We are probably one of the highest users of groundwater in the world, and in the cities also we are using a lot. So in the sense, what has happened is that the understanding of the recharge and the amount, which is the source for groundwater, and the amount of demand, these two are not properly how do you say equated. The reason is that the groundwater recharge is not only due to rainwater recharge. There could be indirect recharge, there could be fluvial recharge, there could be other recharges. That means runoff water may become recharged within the scope of this. It's not necessarily that it goes through the Vados zone like this. It can have cracks. You can have various other mechanisms like we are talking about. Some others have expressed how the lakes could locally recharge and so on and so forth. So in short, we have depended on too much of groundwater use or so many, but we don't have good scientific temperament and invested in assessing the groundwater stocks. The groundwater stock and its changes are very critical. They may not have any relation to the depth to which someone will drill. The groundwater stock and depth to groundwater drilling are not. Someone will say groundwater is at a depth of 1,000 feet. That is not that might be a drill well which is drilled to 1,000 feet, probably. And similarly, the failure of a well has nothing to do with the stock. So considering that there's a lot of myths around in this system, it is important that we need to segregate stocks. That means I need to know what is the resource. There could be still a failure of a well. The failure of a well could be that one competing well with another well could fail one well. So it is possible that failures can happen in various ways. So one needs to look at what are the reasons for a failure of well? Is the stock of groundwater in that area has come down? That's why the wells are failed, or there could be other reasons. Similarly, the recharge pathways. We all assume that if we do this, my recharge increases. But is it evidential? Is it information exists to show that all these best practices and recharge generating mechanisms have created recharge? So I think that's why I said the lacuna is that we have not assessed properly the recharge. There are several reasons. I think several people before me would have spoken on it. The reason is that we have invested very little on monitoring. Our monitoring network is very, very small. For example, if you're talking about 250 watts, we don't have a proper groundwater stock variations with the time. We may have a good rainfall variation with the time. We may have a temperature variation with the time. I think Jagdish was showing how the land surface temperature is showing variations and things like that. But do we have so much of information about groundwater, even though we are probably the pumping probably about 1 MLD per square kilometer, something like that. So that means the big question probably is, and it will continue to grow. And more so during a non-rainy years, the amount of groundwater use will increase because the other sources of water will come down. So the proportionate rate or proportionate quantity of groundwater will increase. So in that circumstances, we should have a proper yardstick to know at the local scale what is happening to the groundwater stock. Then we know ahead of the time that at this groundwater stock, there could be failures of wells, there could be some other problems and so on and so forth, that the quality could deteriorate and so on. So we should have a proper assessment of groundwater at a very, very fine scale. And probably first steps are made in this exercise to make a good assessment first, which will feed into decision-making process. I think some other speakers have already spoken about groundwater management, decentralized groundwater management at ward or sub-ward scale, so that we have a proper understanding. Plus, probably each ward should become a decentralized water management, not only groundwater management. It should be a water management plan. That means excess water should be recycled water, or whatever water coming out of various apartment complexes should be able to be circulated locally, because it cannot be transmitted across. So that means there has to be a ward level management, because every ward may not have a lake. Every ward may not have some other sources. So maybe we need to have a proper assessment plan on ward or even finer scale, maybe at finer grid scales. And if we do that, there could be a better assessment, and it also gives input. So in 4 points probably, one is you need a good monitoring network which feeds into the scientific information. The science should come out and say what are the stocks, what's happening to the stock. It's like a stock market, right? So we need to have a stock market or stock of groundwater, so that it can be fed to the decision making process. Parallelly, there should also be an augmentation of groundwater, because we see so much of runoff will happen during flood years. Flood years and drought years are going to be separated. They are not going to happen in the same year. So usually you have few flood years, you have few drought years. In these flood years, you should put the groundwater as a store and use it back in a drought year. That's how groundwater is used as a buffer everywhere. So during flood years, we have to somehow create a good infrastructure to push all the water as much as possible into the ground. We may have to augment this infrastructure. We may have already an existing infrastructure, like I think probably lakes and presence of other infrastructure, various other harvesting operations. But still, probably that's not adequate. Maybe we have to push more water in. Geology comes into complexity of a challenge. We need to understand which places you can harvest. Bangalore is a hard rock, which is a granite. As you can see, you walk on granite. So it's not easy to push water below. So one needs to find out which are the ideal places for pushing the water. Then the third point is we need also, as I said, ward level decentralized way of participatory management. To do that, we need people to understand groundwater a lot. If we don't understand, there will be a lot of myths. The myths are more both in the science, more in everything, because science is also less understood. Practice, applying them and studying them is important. The last is there has to be a good, how do you say, that's what I think people have spoken. So we're looking at an outlook and things like that. The idea is some kind of a simpler forecast. You need to have some idea into the dry season, starting from November, December. What would happen to the groundwater conditions going forward? It's similar to, we say we have a weather forecast, we have some other forecast, temperature forecast, but we don't have a forecast for flow in rivers, or we don't have a forecast for flow in hydrological forecast. So we call this as a groundwater outlook, using the information available a priori. Use that to project at all the places, so that you have a system where one can make proper decision making. This will go in the form of an advocacy. It can go in the form of advisories to the people, to the participants. So the biggest challenge is transmitting information of scientific information, the data and the scientific information cycling back to the stakeholders, so that they can do a better participatory management and advisory. This loop has to be completed. Otherwise, we will not be able to, the people who know about groundwater will remain somewhere. The people who don't know about groundwater will continue to use ground. So there will be a lot of chaos to close this loop. Thank you.
Thank you so much, Shekhar. We are heading towards the end of this session. Jay, you come from the. Is it? Oh, okay. We have two innovators with us, Srinath and Swapnil, Duac Tech and Uravu Labs. Srinath, would you like to go first on this, on your technology?
Okay, and can you hear me now?
Yes, we can.
Okay, yes. Yeah, I'm Srinath Bolisetti. I'm from Switzerland in ETH Zurich, where 22 Nobel laureates, including Einstein, was from here. So I'm here since 20 years. And why I'm here is basically I'm from Nalgonda district in Telangana right now. And I came from a very water problem place to very good water rich country like Switzerland, where I am right now. Okay. So meanwhile, during this panel, I like to understand. Means I know that there is a lot of water scarcity problems are there in India, especially in Bangalore. But I was very fascinated how they handle the water crisis here in the developed countries, because of course Bangalore is a lot of population, but there are also many cities in Europe, including London, including Berlin, including many developed countries. Uh, they have a lot of population as well, and they are also maintaining this water problem very efficiently. And why Indian cities are not able to solve these problems very efficiently? And we are not like states in the Middle East, where we don't have rainfall and all. But how these European countries resolving these issues very efficiently is the net zero policy. Net zero policy means if you use 1 liter of water, you need to clean 1 liter of water. Okay, that is highly efficient, and that's why they never face water scarcity problem. Even the water which is in the they provide 24 hours water supply for the entire country. And you are not allowed to dig your own borewell in our country in Switzerland without the government permission, because they supply 24 hours of water. At the same time, what is very important is even I can go to bathroom and I can drink the water from the bathroom as well. So that much efficient and pure quality water is providing in this country. Okay. And that is the water purification and water quality management should be done on the government scale. Okay, the net zero policy. Forget about the government perspective and all, but on the local level, so on the household level, why we are not able to have a net zero policy? Like, as I heard a lot of conversations during the last 2.5 hours, and there is interesting discussions about everything, including the other innovator. He shown about the net zero related to toilet water, which is also reused. And what we are doing is the major problem in India and in Indian cities is we are using the technologies which is not needed, especially the reverse osmosis. Who is drinking the reverse osmosis right now in Bangalore? Entire all the people. And the real problem with this kind of technologies is, in order to clean 1 liter of water, you need to put 2 liters or more than 2 liters of water into the drainage. Everybody knows it. And if you have an AquaGuard water filter, basically you in order to drink 1 liter, you need to put 2 liters into the sewage. Okay. And these problems are also need to be considered. And also the sewage water treatment need to be done in more efficiently by the community or by the cities and these things. And Blue Act, what we really provide it as a solution is the net zero. Okay, net zero in the sense we have zero water wastage, converting water from dirty water to the clean water. we have an adsorbent, which is a cow milk based protein. Okay, this protein act as an adsorbent to clean the water. Okay, and it will remove multiple pollutants, including inorganic, organic, as well as biological pollutants. We have 4 patents related to this one. And what I want to say here is, if we want to have an efficient technology, and that can resolve a lot of the water wastage problems, and by using our technology we can treat even the city of Rome municipal water, or in the many major cities, we can clean the water, especially with the heavy metals, organic pollutants, pesticides. This will be resolved. And also the government also need to consider the wastewater treatment plants installation is mandatory. They need to improve, they need to increase. And here the wastewater treatment plants in Europe, there are major source of money. Okay, they produce biomethane from that one, they produce electricity from these wastewater treatment plants. They run by their own funds, they don't ask for money, because this wastewater treatment plant is also a source of major income. So if these things are implemented, then there will be a bigger future, because water is life. Without water, there is nothing will exist. And if humans are facing the water challenges, what is happening to the animals? And what is happening globally? And we are the country with rich rainwater sources. So I think if water is not available, water is not existing, then the life will dissolve at that point. So by using the technologies, the modern technologies, which is energy efficient and sustainable, this will solve this kind of water challenges. So thank you very much for your time. I don't want to take a lot of time, but in short and sweet, I want to finish it.
Thank you, Srinath. Wonderful words. Sapni, I'm sorry you have been waiting.
Sure, no worries. Best for the last. So thank you so much, first of all, for having me on this panel. And I have been actually come across many of these experts over the last few years. Was even working on my thesis on wastewater treatment for GKVK. So I've been like kind of outsider, insider in the water space. But for us, especially at Uravu Labs, where I'm a co-founder, the thought process was, while there are existing technologies which many have been already developed, it's more about how to implement it and how to take it forward on a city to community scale. What we were looking for, what could be the next technological leaps you can take in the water space. And while many of my expert panelists spoke about wastewater, even rainwater harvesting. One other source what we look at Uravu Labs is atmospheric moisture. Now, to first even understand why do we even need atmospheric moisture, does it even make sense in the first place? So one reason is that atmospheric moisture is almost 6 times what we have in all the world's rivers combined. So if you just look at the amount of atmospheric moisture present at given any point, it's huge. If I just take the case of Bangalore, around 700 square meters, and I take about 100 meters as the usable air column where I can extract moisture from, I already have 500 to 700 times the water required by Bangalore at any given day. So there's already enough moisture present in the air above Bangalore to not only fulfill Bangalore's demand, but maybe 500 such cities demand. But another thing which is also very interesting with water atmospheric moisture is, in just 8 to 10 days, all this moisture replenishes naturally. So you have constant evaporation happening from surface bodies, from rivers, lakes, even from plants are transpiring. And Mr. Jagdish was talking about the green water. So there's an atmospheric river above our head already, and it's replenishing in 8 to 10 days. When it comes to groundwater, studies show that only 6% of groundwater today in the world is renewable, which means it takes less than 50 years to recharge naturally. What we are proposing now is more like an artificial recharge, which like over time has to be built, thought of, planned. But natural recharge of groundwater takes on an average 1400 years. So it's not going to happen in our lifetimes if we just let it nature happen. We have already gone way forward in not enabling that because of all the construction, not having natural systems to take that rainwater and also make groundwater recharge appear natural. So for us, this was the idea that, can you tap into an alternative source, which is abundant, which is infinite, which doesn't need a lot of transportation to happen, so that you can shift to more decentralized, sustainable solutions. Now, how we have enabled this technology is we use a material to absorb the moisture from the air and then applying renewable energy sources in form of heat at 60 degrees Celsius, we then extract very high quality water. So your water you get is almost ultra pure, which means you don't need any further purification. You don't need reverse osmosis. So there is no wastage. You can use this water directly even for a pharmaceutical application. So whether you get Kaveri water and then your DM, the ionization, many other processes to reach then that kind of grade of water, we already have that water as part of the process. So you save a lot on these costs, you save a lot on these wastage, which would otherwise would happen. But being a nascent technology, I can't claim and go ahead and say, oh, there's so much water in the air, technology is there. Can it then solve a lot of problems associated? So now the next question is, where does it make sense? Where does it really make sense to use it? One application, what we have done in Bangalore is looking more at the beverage space. So you have hospitality customers, you have even beverages, retail. So today what they do is if you want to have a plant of any packaged beverage, they'll use a groundwater borewell, use a reverse osmosis, and then package that water and deliver it. Whereas in our case, such a plant which we use through our technology will save almost 2 to 3 times the groundwater. So in the last 6 to 8 months, we have already saved more than 6 lakh liters of groundwater from our facility, while also serving almost 5 lakh beverage products to many of our customers all across Bangalore. So in that way, we are indirectly saving it, and that's where I also think we need to bucket how water is being used and which departments or which segments are using it. So roughly 1400 million liters per day is Bangalore's demand, out of which roughly 900 is for domestic residential users. But the rest 500 is where I think the technology interventions like this make more sense, because you have industrial use cases, you have commercial use cases, which again occupy almost 80% of the remaining 500. And that's where people also have the ability to pay. Businesses have to use it for running the businesses, so they can value water more than a domestic use case where it's naturally accepted that government and municipalities should supply it. So I think that's also a point of thought we should be putting into that. Okay, if there are technology interventions, where do they make the most sense? So I think one of the fellow panelists was also talking about why RO or RO stations still exist. Why can't we outright ban them? So similar question is, why can't we outright ban groundwater used by many of these industries, where that they are anyway can source their water from other sources, technologies do exist. Why can't they not use other potable sources like wastewater or maybe atmospheric water? So I think some policy intervention from that side will also help, probably not for the entirety of it, but then there is easily good 100 to 300 mld of water which is going for industrial use cases where this can make a lot of sense. For us also, one of the other use cases we are looking at it, how can we even eliminate a cooling tower out of all this industry? So what usually happens is a lot of heat is getting generated and you will have water flowing through it, cooling all the machinery, and it goes to a cooling tower where again that water gets evaporated. So what our technology can do is intervene at the point before hot water or this heat enters the cooling tower and save all that water. So if you have a big factory or even places where a lot of waste heat is there and using a cooling tower, we can outright eliminate good 80 to 90% of that water use. So there are many interventions like this which can happen in the industrial space. I'm not very sure of this technology in the domestic space, while there could be applications for drinking water and all, but the impact won't be as large and the cost is still prohibitive, at least in the short to mid. But looking at industrial applications, we are quite hopeful for that. We have already scaled to around 4,000 liters per day in Bangalore at our facility near Hennur. So full savings on groundwater, 100% powered by renewable energy. So we have already shown that, it could be done at scale, could indirectly save a lot of groundwater for nearby communities. And I think Bangalore has enough atmospheric moisture to start solving some of the use cases, at least in the industrial space.
Thank you so much, Swapnil. This actually completes the list of panelists, the talk of this, the list of panelists we have. And I think we're already behind schedule for about 20 minutes. Last closing remarks from Ram Manoharji and Professor Ramchandra on the next steps, if at all you have something in mind, which, I mean, obviously we'll make notes of the entire recorded session and we'll send a transcript of this this meeting. But some closing remarks from Ram Manoharji and Ramchandra sir.
Yeah, actually, one of the things I was loudly thinking is we need to have the carrying capacity study done for the Bangalore on priority before we allow any further growth in the city. I had worked in the various committees of the government, state level environmental appraisal committee. I've noticed that, BWSSV always gives the NOC, irrespective of whether water is available or not. They give the letter saying that subject to the availability of water, we will provide the thing. That is, I think the BWSSV should stop issuing such NOCs till the carrying capacity study is done for the region. So that we need to take stock of the what are the resources we have and what is the capacity we can withstand. The second thing is that we should make the use of RO for the treated water. Kaveri water, we should ban that. I have seen in many the households they are wasting this the tap water by using the RO. There's a large scale wastage of water is happening. That I think BWSSV should ban that. Third thing is rainwater harvesting has to be made mandatory. When we before BWSSV gives the connection to any new construction, they should make sure that that house has the rainwater harvesting sum and also associated the plumbing is implemented in place. Then only they should give the meter for the BWSSV connection in the city area. If we do that, then only the things will work. Otherwise, we are going to talk about it and we will face the problem. And the last point is about the desilting of Vattur and Belandur Lake. There was a comment saying that that part of Bangalore, there was a water crisis because of the desilting work. These are the wrong information being circulated in the system. Because when the before rejuvenation of the lake, I have the groundwater table in the region. And after a year of rejuvenation, when the rejuvenation work was started, how the things have improved in the region. Some of the local people, I have a regular meeting with the local people. They have come and given me the data of the groundwater. Even the local ex-councillor, the lady came and told me that her well, the water level increased by about 85 feet within the 12 months of the desilting. That is where, when we have the science-based intervention, we should also make sure that the wrong informations are not given in the system. So probably that we should put a halt to that. And that's where, as the scientist, it's our responsibility to communicate to the wider structure of the system, to say that desilting certainly helps in recharging of the groundwater. That is, I have many data. And I have also made this data available to the public. I have at IISc, we have a Bangalore Lake Information System or a BLIS. Similarly, Bangalore Urban Information System to visualize the growth of the city. And many of the Bangaloreans are used the thing. And of course, the media people also have used it extensively. That's how the science can help in when the science reaches the society, there will be a sustenance of the natural resources because the appropriate policy decisions should be taken. Thank you very much for inviting me and giving the opportunity to share whatever I have learned over a period of time. Thank you.
Thank you so much, Professor Ramchandra. Ram Manoharji, final comment from you?
So I thank all the participants from various scientific community and across sectors for being actively participating in the knowledge building exercise of the IIC. As we all understood the problem, now going forward, the solutions and implementing the solutions. As we all aware that the solutions are multitude and it involves multiple stakeholders from all the domains, starting from scientific community to the technical experts, administrators, and influencers, and a mass scale public as a community. So all the levels of cooperation and uniformed vision and comprehensive approach is required for the overall integrated comprehensive water management system in Bengaluru. We know today what we are bringing in additional water may not suffice in next 2 to 3 years unless we proactively take steps in line of conserving the existing fresh water, conserving the water bodies, pushing for maximizing the usage of treated water in the domains which we can use, be it a commercial, industrial, construction segment, and protecting the underground water, and most importantly, use of technology in water management, advanced technology like AI-based technology, robotics technology, many other technologies have to be implemented in a scale, not on pilot. Whatever the research projects have been done in the Institute of Science and other various academic institutions and research and development wings, we should bring that on a scalable, implementable model. There should be a connecting bridge between knowledge tank and the administrative wing so that the technology will be adaptable for the citizens' use. Then largely we need a community participation. So far, water management become a bureaucratic subject or think tank's thought process. From thinking of knowledge society, action of administrative society, and participation of public community. These are the three levels this has to go on. So far, we have seen the water management only left to the knowledge community and to the administrative community. We have not gone to the public participation. That's what the BWCC is aiming for. Unless and otherwise, 1 crore 40 lakhs people of Bengaluru citizen are not aware about the impending crisis of water management and the need for public participation in the overall water economy, then things cannot change in a much larger scale. In fact, we as a public authority, we are aiming for that kind of public participation. And lastly, we have to segregate the different waters like black water, grey water, safe water, clean water, then drinkable water. There are different categories of water. Right now, what we are doing, we are mixing the black water with the grey water, which would have been decentralized treatment would have been done at the ground level, be it a commercial complex, be it an apartment area, be it a residential layouts, where there are a lot of scope for decentralized segregation of black water and grey water. This area we have never executed because we have mixed the sewage with the grey water and augmented the capacity of the sewage. That has put up the pressure on the existing treatment plant system. That has put up pressure on the existing drainage pattern, and that has put up pressure on the lake bodies. So the goal of all of us to develop technologies and implement the administrative measures to see that, like what we have done in the solid waste management, segregating the organic waste and inorganic waste, we should start segregating the grey water and black water so that the grey water can be recycled at the local level and thereby it can be reutilized, reuse of recycled water there in the field itself. Such recycled water like bathroom water, other kitchen use water, such waters are many more. That is a quantity maximum. About 50% of the water is grey water. Remaining about 50% is roughly the sewage water. So that this recycled water should again looped into the toilet flushing and other secondary uses like gardening and cleaning purposes, so that every individual household, every apartment unit, every commercial complex will become sustainable on its own. We can supply limited amount of fresh water. We can take out limited amount of sewage water, so that the pressure in the existing infrastructure will come down. So we have to develop technologies for grey water recycling at the ground level. For that, I need your cooperation. This will give a medium-term solution for our current problem, as well as it will give a long-term implications in infrastructure creations like a supply of fresh water or treatment of sewage. That capacity what we are building, if we are not segregating this aspect and if we are not focusing on recycle of this treated water at the local level, decentralized level, and how much solar capacity we built in both the fronts, fresh water supply and sewage water treatment, that will become insufficient in the days to come. Therefore, I request the knowledge community to focus the research area in grey water segregation. If you already have developed technologies, please discuss with us and we will provide support to scale it up in the larger interest of the Bengaluru. Therefore, with this concluding mark, I thank all the participants for arising to the occasion and rising to the situation and coming forward. Not only today, even last 45 days, we are getting lot of support from the Indian Institute of Science and Biome Institute, Well Labs, and Professor Ramachandra in specific, and other professors like Dr. Mohan Kumar and Professor Sekhar Ji, Professor Lakshminarayana Rao, and many others. They lack of time, I may not be able to spell out the name. So all these people have collaborated and very well supported us, and we wish this support should not be a temporary measure. It should be a long-standing effort of departmental coordination, interinstitutional coordination. For that, this particular convention, this particular conference will be a starting point, and we see that this should be a starting point of relationship and it should be continued forever. And we should keep discussing on a quarterly basis and prepare an action points. As we already mentioned, there are a lot of points have been discussed. Unless we act upon the points have been discussed, we are standing in the same place where we have started. So simple idea of putting aerator needs lot of administrative muscles. Like simple technologies being developed in the academic institutions need to have been scaled up to be implemented in the field. We as a BWSS, we assure you that all the support required from BWSS will be extended to the knowledge community to give out the solution which is scalable, implementable, cost effective, so that we can solve this crisis in a long-term basis. And we look forward for a very bright future for Bengaluru. And I assure you that whatever steps have been taken are in the right direction with the support of the knowledge community like you. So hopefully in future also we'll able to handle the situation in a better way, not only in short term, also in long term. Thank you very much.
Thank you so much, Ram Manohar ji. Thanks for your time and thanks for your words. With this, we end this